Vijnanam paramam dharmam, Vijnanam paramam balam, Vijnanam paramam shakti, Sarva dharmanushthanataha. Science is not just a pursuit of knowledge, but a guiding force of righteousness, strength and power. Science is the strength that drives progress, the power that propels society forward, and the means by which we fulfill our responsibility to humanity and the world. Through the lens of science, we gain the strength to solve problems, improve lives, and drive innovation. As Steve Jobs once said, innovation is the ability to see the changes as an opportunity, not a threat. A very good morning to everyone. On behalf of Mangalore University Biochemistry Program, I feel both honored and privileged to have you all here for the inaugural function of Global Initiative of Academic Networks GIAN Program on Developing Cancer Model in Vitro and In-VIVO Advantages and Limitation, which will be held from 18th to 22nd March 2025. To inaugurate this GIAN program on developing cancer model in vitro and in vivo, advantages and limitations, today we have with us Professor P.L. Dharma, Honorable Vice Chancellor, Mangalore University, to preside over the inaugural function. Dr. Nagaraj Nagatihalli, Assistant Director for Basic Science Research and Associate Professor of Surgery, Pancreatic Cancer Center, Sylvester Pancreatic Cancer Research Institute, University of Miami, Florida, USA, as our resource person. Going on with this, again I would like to welcome you all for this auspicious occasion. Prayer is a mighty instrument, not for getting man's will done in the heaven, but for getting God's will done in the earth. As we prepare to commence this event, let us all take a moment to center for ourselves in the spirit of togetherness to take the blessings of the Almighty. Now I invite Shravya Naik and team to lead us in the moment of reflection.
ಬೆಳಗೋಕೆ ಈ ಬದುಕು ಜ್ಞಾನವೇ ಬೆಳಕು ಬೆಳಗೋಕೆ ಈ ಬದುಕು ಎರೆಯುತ್ತ ಜ್ಞಾನ ತೆರೆಸುತ್ತ ಕಣ್ಣ ಈ ವಿದ್ಯೆ ಹೊನ್ನ ಕಿರಣ ದಿನ ಪಾಠ ಪಠಣ ಗುರು ಬುದ್ಧಿ ವಚನ ಇದು ವಿದ್ಯಾದಾನ ತಾಣ ಪಡೆದಾಗಲೇನೆ ಸಿರಿ ಶಿಕ್ಷಣ ನಮ್ಮ ಅಂಧಕಾರದ ಮನ ಮಂಗಳೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯ ಮಂಗಳೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯ ನಮನ ನಮನ ಜ್ಞಾನವೇ ಬೆಳಕು ಬೆಳಗೋಕೆ ಈ ಬದುಕು ಜ್ಞಾನವೇ ಬೆಳಕು ಬೆಳಗೋಕೆ ಈ ಬದುಕು ಜ್ಞಾನದೇ ಗುಲವೇ ಬೀಡು ಬಿಟ್ಟಿದೆ ಕಡಲಿನ ತಡಿಯಲ್ಲಿ ಅರಿವು ಮೂಡಿಸುವ ಗುರುವೇ ದೇವರು ನಮ್ಮ ಈ ಗುಳಿಯಲ್ಲಿ ಎಲ್ಲ ಸಾಧನೆಯ ಮುಟ್ಟು ಮೆಟ್ಟಿಲು ಹತ್ತೋದಿಲ್ಲೆ ಮೊದಲು ವಿದ್ಯೆಯೇ ನಮ್ಮಯ ಹಕ್ಕು ನಾಳೆಯ ದಿಕ್ಕು ಜೀವನದ ಸೆಲೆಯೂ ಜ್ಞಾನವೇ ಬೆಳಕು ಬೆಳಗೋಕೆ ಈ ಬದುಕು ಜ್ಞಾನವೇ ಬೆಳಕು ಬೆಳಗೋಕೆ ಈ ಬದುಕು ಎಳೆಯುತ್ತ ಜ್ಞಾನ ತೆರೆಸುತ್ತ ಕಣ್ಣ ಈ ವಿದ್ಯೆ ಹೊನ್ನ ಕಿರಣ ದಿನ ಪಾಠ ಪಠಣ ಗುರು ಬುದ್ಧಿ ವಚನ ಇದು ವಿದ್ಯಾದಾನ ತಾಣ ಪಡೆದಾಗಲೇನೆ ಸಿರಿ ಶಿಕ್ಷಣ ನಮ್ಮ ಅಂಧಕಾರದ ಮನ ಮಂಗಳೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯ ಮಂಗಳೂರು ವಿಶ್ವವಿದ್ಯಾನಿಲಯ ನಮನ ನಮನ ಜ್ಞಾನವೇ ಬೆಳಕು ಬೆಳಗೋಕೆ ಈ ಬದುಕು ಜ್ಞಾನವೇ ಬೆಳಕು ಬೆಳಗೋಕೆ ಈ ಬದುಕು
As we commence this event further, it's our duty to respect and welcome our guests and all present here. So I request Professor Chandrasekhar J. Joshi to give introductory speech and about the GIAN program and formally welcome the gathering.
Good morning all. Honorable Vice Chancellor, Professor P.L. Dharma, Distinguished Subject Expert of the GIAN Program, Dr. Nagaraj Nagatehalli, esteemed guests and dear participants. It is with great honor and immense pleasure that I extend a warm welcome to you all to the one-week GIAN course on developing cancer models in vitro and in vivo, advantages and limitation, organized by Biochemistry Program at Mangalore University. The Global Initiative of Academic Networks, famous as GIAN, is a prestigious program under Ministry of Education, Government of India, aimed at leveraging the expertise of globally renowned scientists and entrepreneurs to enhance India's academic landscape. This initiative strengthens the country's academic resource, accelerates quality reforms, and elevates India's scientific and technological capabilities to a global standard. Mangalore University has conducted numerous GIAN programs in the past, and this marks the second one of the academic year with more in the pipeline. These efforts establish Mangalore University as a premier institution fostering global academic collaborations under able leadership of our Honorable Vice Chancellor. Cancer remains leading cause of morbidity and mortality worldwide, necessitating innovative research and multidisciplinary approach for effective treatment. This program has been meticulously planned as a platform for knowledge dissemination and experts in the field, offering valuable insights into the complexities of developing cancer models and their applications. We are privileged to have Honorable Vice Chancellor Professor P.L. Dharma sir presiding over this inaugural session. Professor Dharma is a distinguished academician and accomplished orator, renowned for his multilingual proficiency. Under his visionary leadership, Mangalore University is heading towards the attainment of new heights of excellence. Professor Dharma obtained his master's degree in 1998 with first rank and completed his PhD in 1994 from Karnataka University. With an extensive teaching career spanning 36 years in the Department of Political Science at Mangalore University, he has held various academic and administrative positions, significantly contributing to the institution's progressive development. His contribution extends beyond academia into administrative, having served as Registrar in Charge and Registrar Evaluation of Mangalore University. Notably, he has introduced and implemented the self-developed in-house examination software called MU-Links, ensuring a user-friendly and transparent evaluation process. His leadership during the COVID-19 pandemic facilitated seamless university examinations beyond national boundaries, alongside special provisions for students engaged in sports and cultural events. His efforts in digitizing university records from 1981 to 2000 stand as a testament to his commitment to the modernization. Professor Dharma has received numerous awards, including the Excellence and Leadership Award in Education, the Dr. APJ Abdul Kalam Rashtriya Puraskar, and recognition as one of the best teachers for his contribution to the academic community. Recently, in March 2024, he was honored as the best professor in political science for his excellence and leadership in education. Despite his demanding schedules, he has graciously accepted our invitation to grace this occasion. On behalf of the GIAN program, the Biochemistry program, and Mangalore University, I extend a heartfelt welcome to Professor Dharma sir. Welcome you, sir. I request Professor Manjaya, Dean, Faculty of Science, to florally welcome our Honorable Vice Chancellor. It is also a great privilege to welcome Dr. Nagaraj Nagatehalli, fondly known as Nag in academic circle. Our association dates back to our postgraduate days at the University of Mysore, and later he became my mentor during my postdoc fellowship in the USA. Dr. Nagaraj Nagatehalli is a renowned cancer biologist at the Sylvester Comprehensive Cancer Center, University of Miami, School of Medicine, USA. He serves as Assistant Director, Basic Science Research and Associate Professor in the Department of Surgery. Dr. Nagatehalli obtained his postgraduate training in biochemistry from the University of Mysore, followed by PhD from Defense Food Research Laboratory and the University of Mysore under DRDO National Research Fellowship. Prior to 2015, he held position as postdoctoral fellow, instructor, and research assistant professor at the Vanderbilt Cancer Center, Vanderbilt University, USA. Dr. Nagatehalli has been the recipient of multiple prestigious awards, including Ed Nelson Research Award, Young Investigator Award, and scholarship from American Institute of Cancer Research, Pancreas Fest, and American Association for Cancer Research. His exceptional research contributions have earned him Stanley Glaser Research Award, Sylvester Faculty Travel Award, and Florida State James Esther King Biomedical Research Award. He has served as an ad hoc grant reviewer for esteemed institutions such as National Institute of Health, Department of Defense, Wellcome Trust, Department of Biotechnology India, and several international research funding bodies. He has published over 60 peer-reviewed research papers in prestigious cancer journals and secured multiple NIH R01, R21, R03 grants alongside institutional and Florida State biomedical research grants. His dedication and passion for cancer research have led him to attain the prestigious position of Assistant Director of Basic Science Research at the Sylvester Pancreatic Cancer Research Institute, University of Miami, at remarkably young age. Recently, he secured $1.5 million, that is approximately 13 crores in Indian rupees, in research funding from Florida Cancer Innovation Fund Research Grant for an innovative project. He is currently handling 8 such active research grants, has completed 12 projects, and has 4 pending. Beyond his professional achievements, Dr. Nagatehalli actively contributes to cultural activities. He serves as the Joint Secretary of the Association of Kannadakota USA, akka, it is famous as, and plays a key role in Nandi Kannadakota of South Florida, where he was instrumental in establishing Kannada School in Miami and teach Kannada to American kids. On behalf of GIAN program, the biochemistry program, and Mangalore University, I extend a warm welcome to Dr. Nagaraj Nagatehalli. Welcome you, sir. I request Professor Monica Sadananda to florally welcome Dr. Nagaraj Nagatehalli. Monica, Madam, she is the IQAC Director of Mangalore University. I take this opportunity to extend a special welcome to all the distinguished participants who have traveled from various parts of India to be part of this program. Your presence adds immense value to this academic endeavor. I also acknowledge the esteemed presence of Professor Satish Jijay from Coimbatore University, along with several other distinguished scholars. A warm welcome is also extended to the Dean, Directors, Chairpersons, Faculty members, Research Scholars, MSc students, and non-teaching staff of Mangalore University, as well as members of the media. Your presence and support are invaluable in making these events a success. Over the next 5 days, we engage in thought-provoking discussions, exchange pioneering ideas, and explore new perspectives that will contribute to advancement in cancer biology. I encourage each of you to actively participate and connect with the fellow teachers and maximize this unique learning opportunity. Thank you one and all.
Thank you, sir. I welcome you too. Ladies and gentlemen, as we begin this momentous occasion, it is a cherished tradition in our culture to inaugurate this program by lighting the lamp. So I kindly request our chief guest along with all the other dignitaries to grace us their presence for the occasional lighting of the lamp. I request Ravi Naik and team to preside over the lighting ceremony.
शुभं कुरु त्वं कल्याणम्
Today, we are honored to have our esteemed chief guest, Dr. Nagaraj Nagathiralli with us. Let's all warmly welcome him to share his valuable insight. Over to you, sir.
Thank you, everyone. Thank you. Honorable Vice Chancellor Dr. Dharma, GIAN Course Coordinator Professor Chandrasekhar Joshi, respected teachers, faculty, and also students, and respected the GIAN course participants. I'm really very honored to be here today. I'm overwhelmed. We started this project, thinking about cancer biology, I think a year ago. We were just one day we were talking, and then we decided, we have to help some students at least, whatever we can. Whatever we have to write something to help the students. So, but what is the way I can come and give a talk? But that is not the important thing. Important thing is, delivering a lecture is one thing, and second also, interacting with the students and helping them developing cancer biology program and helping them conduct the research is a key impact, factor. It can impact the, researchers in India, also young minds in India. They can change the way they think, can be, how they can do research like Western, countries or Europeans, any other country people, right? That's, I think, the key factor for any young minds to, do something beyond what they think. We were all here before, right? I worked in India. I was a scholar, and I know the difficulty. But now things have changed in India. So, but the same way it has changed in other countries also. So whatever we learned last 25 years in the cancer biology, we thought, we can actually teach something here in Mangalore University. So we selected Mangalore University. The reason we wanted to read it because of Joshi, and also the culture in Mangalore University has changed, and we have seen after Joshi moved to Mangalore University, and he's talking about differences in many universities and also Mangalore. So we thought, I think this is the time I think we should write. So GIAN, I think this is one of the great place for GIAN to conduct the program, and it's a beautiful idea from Indian government to have this type of program, especially for the next generation scientists, right? And also the cancer research, conducting cancer research in GIAN program, I think this is special. This is one of the only program that I think in GIAN we are doing. So I think is important. Please utilize all these 5 days, interact with us, and I can teach whatever I know, I've learned all these years. So either directly, indirectly, we will be there to help you to establish cancer program, establish cancer research in your lab or in your university, or if you join in even industry. So we can help you develop this program. Studying a disease like cancer is an important thing. If you study and understand biology, we can treat them. If you don't understand, if you don't study, you cannot treat them. It's important to study and understand so that we can treat them right. So to treat them right, we have to understand the biology. We always think that we understood. No, never. There is always this huge data system here, over there. And every day there is the data flowing. So we have to be ahead of that. Means that we have to learn every day. We have to, work hard every day. So then only we can reach and we can treat these patients. I mean, in India, it's growing. You all know the government is actually helping developing programs in cancer research because they see that what's going on here too. So it's important for us to at least start thinking today so that we can change tomorrow's, in a way that we think for the patients, right? As a biologist, we always think about the laboratory research, right? No, we have to think beyond. Like Dr. Dharma was saying that we have to have the interactive program, different department, different universities. It is true. That is how that we were able to treat today many patients. For example, pancreatic cancer, which I work, when I started pancreatic cancer, the survival was only 5%. People were dying. Many people died because even though you have money, they will never be able to treat those patients. But today, the 5% increased to 13% only because the researchers came in and they started working every day. So now it's 13%, means that if the patient is dying in 5 months, now they can at least survive for 1.5 years. That is huge in pancreatic cancer because that they never thought that they can do that, right? So now there are many drugs are coming. The drugs are coming because of the research. So that's why we know that there is a struggle in India, also struggling everywhere. Where I coming from, we struggle too. You were saying many grants, but we struggle to get even the next grant. The grant is for developing something which is unique, which is for the patients. So we think that way. So that is important. Grant is not for having money in the laboratory. No, grant is for developing something so that it will help people. So that's why we struggle every day so that we can save some more patients, some more people who has this disease. So when I joined pancreatic cancer program, very few investigators were there. Today there are a lot of investigators in pancreatic cancer field. But one or two of the work that we have conducted is translational, that we went to clinical trial. That the work I did, two clinical trials, we were able to save patients. So important is that I'm going to teach next couple of days that you have to think differently. Then only we can actually establish biology towards something to someone, somewhere, someday will help, right? That's why it's important, this program. That's why I was telling Joshi, we have to write. If we don't write the project, we will never be able to teach the students, never be able to teach the researchers and tell them what is important. So this is the way that we can tell this is what is important, right? Otherwise we will never be able to, and you will never be able to know that, there may be, you have to go to some other country or some other institution to learn, but in this type of institution, we have to come and tell you. That's very important. That's why I was telling him, we have to do this. So we are doing it. So let's do next 5 days, learn together, and we discuss together, interact, and establish, so that we all learn the cancer something which is unique. We always will be there. It doesn't matter after 5 days. We will be there to help you if you want to develop something or learn something or something to develop, right? Thank you so much, for having me here. Thanks to Dr. Dharma for supporting all this program, and it's very important. I think I'm completely respected that your initiations here, and Joshi for all the hard work, and also you all who are all helping Joshi to develop. And next 5 days, I think it will be successful, but we have to do it right. So let's do it right, and there will be problems definitely, but it's okay. Because at the end of the day, we can all sit together and solve these problems and work together and get it done. Thank you so much. I appreciate it.
Thank you, sir. We are very privileged to have our Honorable Vice Chancellor, Professor P.L. Dharma, with us today. I invite him to deliver the presidential address. Over to you, sir.
Before I speak, dear young friends, ನಿಮ್ಮ ನಾಗತಳ್ಳಿಯವರು ನಮ್ಮ ಕನ್ನಡಿಗರು, ಹಾಗಾಗಿ ನಾನು ಸ್ವಲ್ಪ ಕನ್ನಡದಲ್ಲಿ ಮಾತಾಡಿದ್ರೆ ನಿಮ್ಗೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಅಂತ ತಿಳ್ಕೊಂಡಿದ್ದೀನಿ. ಐ ನೋ ದಟ್ ಬಹಳ ವೈಭವಪೂರ್ವಕವಾಗಿ ಇಲ್ಲಿ ನಡೀತಾ ಇದೆ. ನೀವು ಅದರಲ್ಲಿ ಭಾಗಿಯಾಗದೆ, ನಿಮ್ಮ ಮನರಂಜನೆಯಲ್ಲಿ ಭಾಗಿಯಾಗದೆ ನೀವಿಲ್ಲಿದ್ದೀರಿ. ಆದರೂ ಸ್ವಲ್ಪ ಹೊತ್ತು ನೀವಿಲ್ಲಿದ್ದು ಈ ಥರದೊಂದು ರೇರ್ ಅಪಾರ್ಚುನಿಟಿಯನ್ನು ನೀವು ಬಳಸ್ಕೊಳ್ತಾ ಇರೋದು ನೋಡಿದರೆ ನಿಮಗೆ ನಾನು ಪ್ರತ್ಯೇಕವಾಗಿ ಗ್ರ್ಯಾಟಿಟ್ಯೂಡ್ಸನ್ನು ಹೇಳಬೇಕು. ಸಮಥಿಂಗ್ ವೆರಿ ಸ್ಪೆಷಲ್ ಟು ಹ್ಯಾವ್ ಆನ್ ದ ಕ್ಯಾಂಪಸ್ ಟುಡೇ. ಅದರಲ್ಲಿ ನೀವು ಭಾಗಿಯಾಗಿರೋದು ಬಯೋಕೆಮಿಸ್ಟ್ರಿ ವಿದ್ಯಾರ್ಥಿಗಳು ಮತ್ತು ನಮ್ಮ ಎಲ್ಲ ಹಿರಿಯ ಪ್ರಾಧ್ಯಾಪಕ ಮಿತ್ರರು ಭಾಗಿಯಾಗಿರೋದು ನನಗೆ ತುಂಬ ಖುಷಿಯಾಗಿದೆ. ಹಾಗಾಗಿ ಪ್ರಪ್ರಥಮವಾಗಿ ನಾನು ನಮ್ಮ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರಿಗೆ ಮತ್ತು ನಮ್ಮ ಎಲ್ಲ ಸ್ನೇಹಿತರಿಗೆ, ಫೆಲೋ ಕೊಲೀಗ್ಸ್ಗೆ ನಾನು ಧನ್ಯವಾದಗಳನ್ನ ಹೇಳಿ ನನ್ನ ಮಾತು ಪ್ರಾರಂಭ ಮಾಡ್ತೇನೆ. ಮೊದಲನೇದಾಗಿ ನಿಮಗೆ ಒಫಿಷಿಯಲಿ ಡಾಕ್ಟರ್ ಡಾಕ್ಟರ್ ನಾಗ್ ನಿಮಗೆ ನಾವು ಮಂಗಳೂರು ಯೂನಿವರ್ಸಿಟಿಯ ಪರವಾಗಿ ಮತ್ತೊಮ್ಮೆ ಪ್ರೀತಿಯ ಸ್ವಾಗತವನ್ನು ಕೋರ್ತಾ ಇದ್ದೇವೆ. ಬಹಳ ಮೆಲೋಡಿಯಸ್ ಆಗಿ ಸುಮಾರು ದಿವಸ ಆದಮೇಲೆ ಒಂದು ಒಳ್ಳೆ ಗೀತೆ ಕೇಳಿದೆ ನಾನು, ನಮ್ಮದು ವಿಶ್ವವಿದ್ಯಾಲಯದ ಗೀತೆ. ಆ ಮಕ್ಕಳು ದಯವಿಟ್ಟು ಇಲ್ಲಿಗೆ ಬಂದರೆ ಖುಷಿಯಾಗಿತ್ತು. ಒಂದು ನಿಮಿಷ ಬನ್ನಿ ಇಲ್ಲಿಗೆ, ಯಾರೆಲ್ಲ ಬನ್ನಿ ಮಕ್ಕಳೇ. After so many days I heard our university anthem being sung so melodiously. I think I want you people to beg up, or else you represent them. ಇದೇನು ತಲೆಗೆ ಮುಡ್ಕೊಳ್ಳೋ ಹೂವೇನಲ್ಲ, ಆದರೂ ನೀವು ಇಷ್ಟು ಚೆನ್ನಾಗಿ Friends, this young boy Joshi is known to me when I was a director of the PG department, PG center in Madikeri. ನಾವಿಬ್ಬರು ಜೊತೆಲಿ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ವಿ, ಅಥವಾ ಅವ್ರ ಜೊತೆಗೆ ನಾನು ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದೆ ಡೈರೆಕ್ಟರ್ ಆಗಿ. ಆವಾಗ ಸುಮಾರು ಒಂದು 9:30 ಗಂಟೆಗೆ ಮ್ಯಾಂಗ್ಳೂರಿಂದ ಟ್ರಾವೆಲ್ ಮಾಡಿ ಐ ಯೂಸ್ ಟು ರೀಚ್ ಕ್ಯಾಂಪಸ್ ಅಟ್ ಆಲ್ಮೋಸ್ಟ್ 9:30. ಇಲ್ಲಿಂದ ಬೆಳಿಗ್ಗೆ ಟ್ರಾವೆಲ್ ಮಾಡಿ ಅಲ್ಲಿಲ್ಲೂ ಕೂಡ ಅಲ್ಲಿ ಆಫೀಸ್ ಓಪನ್ ಆಗ್ತಿರ್ಲಿಲ್ಲ, ಯಾರು ಅಟೆಂಡರ್ ಕೂಡ ಬರ್ತಿರ್ಲಿಲ್ಲ. ಬಟ್ ಐ ವಾಸ್ ಒನ್ ಟು ರೀಚ್ ಫ್ರಮ್ ಮ್ಯಾಂಗ್ಳೂರ್ ಟು ಕ್ಯಾಂಪಸ್ ಅಟ್ 9:30. The second person I used to all the time welcome was Joshi. And Dr. Joshi was saying, ಸರ್ ನಾನು ರಷ್ಯಾಕ್ಕೆ ಹೋಗಿದ್ದೆ, ಒಂದು ಪ್ರಾಜೆಕ್ಟ್ ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ದೀನಿ, ನಂದು ಏರಿಯಾ ಕ್ಯಾನ್ಸರ್ ಮೇಲಿದೆ ಅಂತ ಹೇಳುವಾಗ ಒಂದು ಕಡೆ ಭಯ, ಕ್ಯಾನ್ಸರ್ ಮೇಲೆ ರಿಸರ್ಚ್ ಮಾಡೋರ ಹತ್ರ ನಾವು ಏನು ಮಾತನಾಡೋದು, ಒಂದು ಕಡೆ ಭಯ ಆದರೆ ಮತ್ತೊಂದು ಕಡೆಯಿಂದ ಹೌ ಎಂಥೂಸಿಯಾಸ್ಟಿಕ್ ಈಸ್ ಅಂತ ಹೇಳಿ ನಾವು ಅವ್ರಿಗೆಲ್ಲರಿಗೂ ಅಪ್ರಿಷಿಯೇಟ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಬಟ್ ದಟ್ ವಾಸ್ ನಾಟ್ ದ ಪ್ಲೇಸ್ ವೇರ್ ವಿ ವುಡ್ ಹ್ಯಾವ್ ಸಪೋರ್ಟೆಡ್ ಹಿಮ್ ಎಟ್ ಎನಿ ಕಾಸ್. That was a place where I think nothing was there, but still he was interested to establish a small laboratory. When I went to his lab, he was trying to explain, look, this is what I have bought it from my project, and this needs to be maintained, and then you need to give the maintenance cost, which was not possible for me as a director. I understand today establishing a lab, maintaining a laboratory, to conduct a wonderful research, particularly on the cancer, is not an easy job, but Professor Joshi has been doing it. And after he came here, he started doing a very different things with not only you, with your friends. I appreciate Dr. Joshi, your idea of maintaining academic standards as well as maintaining relationship with teachers is something which is very, very appreciable. And I personally thank you and then appreciate the kind of gesture you have. Cancer, I'm absolutely illiterate about it. But sociologically, I can tell how cancer has, created an impact on all of us. There are big stories of successful stories of cancer and cancer patients. And then we come to know that cancer also can be cured and it can be treated, provided you come from an elite background. You have enough money to spend, and therefore there are media today which projects those cancer patients who have recovered and they have become model to all of entire youngsters today. So cancer is not something which ends up in killing the body, but you can also survive. And who are those people who have survived today? And those who have enough resources, they can all the time be accessible to all kinds of medicines, all kinds of treatments, all kinds of facilities available. Therefore cancer can be cured provided you are XYZ. My request with all youngsters today, larger number of experiments are going on in laboratory, larger number of treatments are coming out, larger number of explosions are going on today. It's time for all the youngsters, and that's why the GIAN program is being organized here. See that you also get into this kind of examinations or laboratory experiments or kind of research, that's what he says, right project, so that the medicines today, which is becoming too expensive, which is becoming absolutely inaccessible to larger number of people, become accessible so that each one has some hopes of surviving. We don't know what the cancer is about, who is a cancer patient, and then why the cancer comes in. We just, at least a social science student doesn't understand the source of the cancer as well. But I understand and I read larger number of hospitals are there. There are n number of students, at least every once in a while, die out of cancer. But please think it over. As Professor Nag says, this is one of the premier areas survived today. And he himself has got larger number of projects, and then somehow you people need to see that it is not just you do the MSc program, you also do something called a path-breaking research where you come out with a solution where the medicines becomes accessible to everybody. ತುಂಬಾ ಖುಷಿ ಆಗುತ್ತೆ. ಒಬ್ಬ ಪೊಲಿಟಿಕಲ್ ಸೈನ್ಸ್ ಸ್ಟೂಡೆಂಟ್ ಆಗಿ ಜನೌಷಧಿ ಕೇಳಿದಿರ ಮಕ್ಕಳೇ? ಕೇಳಿದ್ರೆ ತಾವು? ಒಂದು ಕ್ಯಾಪ್ಸುಲ್ಗೆ, ಆಂಟಿಬಯೋಟಿಕ್ ಕ್ಯಾಪ್ಸುಲ್ಗೆ 14 ರೂಪಾಯಿ 15 ರೂಪಾಯಿ ಅಂತ ನಾವು ನಮ್ದು ಯೂಶುವಲ್ ಮೆಡಿಕಲ್ ಶಾಪ್ನಲ್ಲಿ ಮಾರುವ ಸಂದರ್ಭದಲ್ಲಿ, ಅಥವಾ ಯಾವುದಾದ್ರೂ ಪೇನ್ ಕಿಲ್ಲರ್ಸ್ಗೆ ನೀವು 8-9 ರೂಪಾಯಿ ಕೊಟ್ಟು ಒಂದು ಟ್ಯಾಬ್ಲೆಟ್ಸ್ ತಗೊಳ್ಳುವಲ್ಲಿ ಜನೌಷಧಿ ಅಂತ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಕೇಂದ್ರ ಸರ್ಕಾರ ಮಾಡ್ತು. ನಿಮಗೆಲ್ಲ ಅದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಅನಿಸಿಲ್ದೇ ಇರ್ಬೋದು, ಬಟ್ ಒಬ್ಬ ಪಾಲಿಸಿ ಸ್ಟೂಡೆಂಟ್ಗೆ, ನನಗೆ ಪಾಲಿಸಿ ಸ್ಟಡೀಸ್ ಸ್ಟೂಡೆಂಟ್ಗೆ ಇಡೀ ದೇಶದಲ್ಲಿ ಮೆಡಿಕಲ್ ಪಾಲಿಸಿಗಳು ಹೇಗೆ ಬದಲಾವಣೆ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನು ನಾವೆಲ್ಲ ಗಮನಿಸ್ತೇವೆ. ಜನೌಷಧಿ ವಾಸ್ ಎ ಪ್ರೋಗ್ರಾಮ್ exclusively brought to people by the government of India to see that the medicines are available at a reasonable price. ಈ ಜನೌಷಧಿಯನ್ಗೆ ಒಂದು ದೊಡ್ಡ ಲಾಬಿ ಶುರುವಾಗುತ್ತೆ. ಅಲ್ಲಿಗೆ ಬರುವಾಗ ಕಾಂಟೆಂಟ್ಸ್ ನೋಡಿದ್ರೆ, ಆ ಟ್ಯಾಬ್ಲೆಟ್ಸ್ದು ಕ್ಯಾಪ್ಸುಲ್ಸ್ದು ಕಾಂಟೆಂಟ್ಸ್ಗಳು ನೋಡಿದ್ರೆ ಅದು ಸಿಮಿಲರ್ ಆಗಿರೋದಿಲ್ಲ ಕೆಲವು ಸಾರಿ. ಹಾಗಾಗಿ ಜನೌಷಧಿ ಬಡವರಿಗೆ ಅದು ಮತ್ತು ಏನು ಗತಿಲ್ಲದವ್ರಿಗೆ ಅಂತೇಳಿ ಅದರದ್ದು ಕ್ವಾಲಿಟಿಯನ್ನೇ ರಿಡ್ಯೂಸ್ ಮಾಡಿ ಮಾರುಕಟ್ಟೆಗೆ ತಗೊಂಡು ಬಂದ ಬಹಳ ದೊಡ್ಡ ಫಾರ್ಮಾಸ್ಯೂಟಿಕಲ್ ಲಾಬಿಗಳು ನಮ್ಮಲ್ಲಿ ಕೆಲಸ ಮಾಡ್ತವೆ. ಸರ್ಕಾರದ ಒಳ್ಳೆ ಉದ್ದೇಶ ಇದೆ. ಇಟ್ಸ್ ಅ ವಂಡರ್ಫುಲ್ ಡ್ರೀಮ್ ಪ್ರಾಜೆಕ್ಟ್ ಆಫ್ ದಿ ಗವರ್ಮೆಂಟ್, thanks to the government of India. But you know what happened? All the time these people who enter from the back door, they can always get into a big time of lobby, and then they can be controlling the laboratories, and then the pharmaceutical companies produce anything. ಪ್ಯಾರಾಸಿಟಮಲ್ ಅಂತ ಒಂದು ಸಿಗುತ್ತೆ ನಮಗೆ, 25 ಪೈಸೆ ಸರ್. ಎಲ್ಲ ಬರೀ ಹೋಗಿದ್ರೆ ಗೊತ್ತಲೇ ಮಕ್ಕಳಿಗೆ ಒಂದ್ಸರಿ ತಾವು ಹೋಗ್ಬೇಕು, ಜನೌಷಧಿ ಕೇಂದ್ರಕ್ಕೆ ತಾವು ಹೋಗ್ಬೇಕು. 2 ರೂಪಾಯಿಗೆ ಸಿಕ್ಕಿದ್ರೆ 20-25 ಪೈಸೆಗೆ ಒಂದು ಪ್ಯಾರಾಸಿಟಮಲ್ ಸಿಗುತ್ತೆ. ನಿಮ್ಮಂಥ ವಿಜ್ಞಾನಿಗಳು ನಮ್ಗೆ ಹೇಳಬೇಕು, ಅಲ್ಲಿ ಸಿಗುವ ಪ್ಯಾರಾಸಿಟಮಲ್ ಮತ್ತು ಗಣೇಶ್ ಮೆಡಿಕಲ್ಸ್ ಮ್ಯಾಂಗ್ಳೂರ್ನಲ್ಲಿ, ಫಾದಮಲ್ಸ್ನಲ್ಲಿ ಸಿಗುವ ಮೆಡಿಸಿನ್ಸ್ಗಳು ಅದರದ್ದು ಕಾಂಟೆಂಟ್ಸ್ ಏನಿದೆ, ಏನು ಕರೀತೀರಾ, ಇಂಗ್ರೀಡಿಯೆಂಟ್ಸ್ ಕರೀತೀರಾ, ಕಾಂಟೆಂಟ್ಸ್ ಕರೀತೀರಾ? ಇಟ್ಸ್ ದ ಸೇಮ್. ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್. ಬಟ್ ಬಹಳ ದೊಡ್ಡ ವಿಷಯ ಇದು ನಮಗೆ. ನೀವು ಆ ರೀತಿ ಅದನ್ನು ಹೇಳ್ಬಿಟ್ರೆ ಐ ವಿಲ್ ಬಿ ವೆರಿ ವೆರಿ ಹ್ಯಾಪಿ. ಬಟ್ ಎಷ್ಟೋ ಸಂದರ್ಭದಲ್ಲಿ ಆ ಥರದ್ದು ಕೆಲಸಗಳು ನಡೆದೇ ಇಲ್ಲ. ಇಂಥ ನಿಮ್ಮಂಥ ವಿಜ್ಞಾನಿಗಳು ಆ ಥರ ಜನೌಷಧಿ ಕೇಂದ್ರದಲ್ಲಿ ಸಿಗುವ ಮೆಡಿಸಿನ್ಸ್ಗಳು ಸೇಮ್ ಅಂತಂದರೆ ಆಗುತ್ತೆ. ಕಫ್ ಸಿರಪ್ ನಮಗೆ ಕೇಳಿದ್ದೀವಿ, ನಾವು ತುಂಬ ಕಫ್ ಸಿರಪ್ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ದೀವಿ. ಇಲ್ಲೂ ಕೂಡ ಕಫ್ ಸಿರಪ್ ಸಿಗುತ್ತಾ ಇದೆ ನಮಗೆ. ಅದರದ್ದು ಒಳಗಡೆ ಇರುವ ಇಂಗ್ರೀಡಿಯೆಂಟ್ಸ್ಗಳು ಏನು ದಯವಿಟ್ಟು ಅಂತ ಒಮ್ಮೆ ತಾವು ಆಲೋಚನೆ ಮಾಡಬೇಕು. ಬಡವರಿಗೆ ನಮ್ಮ ವಿಜ್ಞಾನವನ್ನು, ಅಪ್ಲೈಡ್ ವಿಜ್ಞಾನವನ್ನು ತಗೊಂಡು ಹೋಗೋದಿದ್ರೆ ನಾವು ದೊಡ್ಡ ಸಂಶೋಧನೆ ಮಾಡಿ, ಲ್ಯಾಬೊರೇಟರಿ ಸೆಟಪ್ ಮಾಡಿ, ಇಂಟರ್ನ್ಯಾಷನಲ್ ಸ್ಟೇಟ್ ಆಫ್ ದಿ ಆರ್ಟ್ ಲ್ಯಾಬೊರೇಟರಿ ಕ್ರಿಯೇಟ್ ಮಾಡಿ ಕೇವಲ ಒಂದು ಎಲಿಟ್ ವರ್ಗಕ್ಕೆ ನಾವು ಸೈನ್ಸನ್ನು ತಗೊಂಡೋದ್ರೆ ಎಲ್ಲೂ ಕೂಡ ಪ್ರಯೋಜನ ಆಗದಿರ್ಬೋದು. ಹಾಗಾಗಿ ನಿಮ್ಮಂಥ ಯಂಗ್ಸ್ಟರ್ಸ್ಗಳು ಇವಾಗ ಸಂಶೋಧನೆಯಲ್ಲಿ ತೊಡಗಿಕೊಳ್ಬೇಕು. ಇಂಥ ದೊಡ್ಡ ದೊಡ್ಡ ರಿಸರ್ಚ್ಗಳು ವಿದೇಶದಿಂದ ಬಂದಾಗ ಮ್ಯಾಕ್ಸಿಮಮ್ ಅವರ ಬೆನಿಫಿಟನ್ನು ತಗೊಂಡು, ಈ ದೇಶದಲ್ಲಿ ಇವತ್ತಿಗೂ ಕೂಡ ಆರೋಗ್ಯ ಜನರ ಕೈನಲ್ಲಿ ಇಲ್ಲ. ಹಾಗಾಗಿ ಅಂಥ ವಿಷಯಗಳನ್ನು ತಾವು ಕೈಗೆ ತಗೊಂಡು ಬಂದರೆ ಬಹಳ ದೊಡ್ಡ ಕೆಲಸ ಆಗುತ್ತೆ ಅಂತ ನಾನು ತಿಳ್ಕೊಂಡಿದ್ದೇನೆ. ಗ್ಯಾನ್ ಪ್ರೋಗ್ರಾಮ್ ಗ್ಲೋಬಲ್ ಇನಿಷಿಯೇಟಿವ್ ಆಗಲೇ ಇನಿಷಿಯೇಟ್ ಆಗೋಗ್ಬಿಟ್ಟಿದೆ. ಸುಮಾರು ಕಾರ್ಯಕ್ರಮಗಳು ನಡೀತಾ ಇದೆ. ನಮ್ಮ ಎಲ್ಲ ವಿಭಾಗದ ಸ್ನೇಹಿತರು ಸುಮಾರು ಇಂಥ ಕಾರ್ಯಕ್ರಮಗಳನ್ನು ಮಾಡ್ಕೊಂಡು ಬಂದಿದ್ದಾರೆ. ಇದು ಇನ್ನು 2ನೇ ಒದ್ದು ನಮ್ಮ ಅಕಾಡೆಮಿಕ್ ಇಯರ್ಗೆ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ನಮ್ಮವರೇ ಆದಂಥ ಕನ್ನಡಿಗರಾದಂಥ ನಾಗತಿಹಳ್ಳಿಯವರು ನಮ್ಮ ಜೊತೆಗಿರೋದು ಭಾಳ ಖುಷಿ. ನಾನು ನಮ್ಮ ಮಕ್ಕಳನ್ನು, ನಮ್ಮ ರಿಸರ್ಚ್ ಕಾಲೇಜ್ಗಳನ್ನು ನೋಡಿದ್ದೇನೆ. ನಾವು ಅವ್ರಿಗೆ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳೋಕ್ಕೆ ಶಕ್ತಿ ನಮ್ಮಲ್ಲಿಲ್ಲ ಇವತ್ತು. ಆದರೆ ನಮ್ಮ ಮಕ್ಕಳದು ಒಳ್ಳೆ ವರ್ಕ್ ಇದೆ ಅಂತ ಆದರೆ, ನಮ್ಮ ರಿಸರ್ಚ್ ಕಾಲೇಜ್ದು ಭಾಳ ವಂಡರ್ಫುಲ್ ಆರ್ಟಿಕಲ್ಸ್ ಪಬ್ಲಿಕೇಶನ್ಸ್ ಇದೆ ಅಂತ ಆದರೆ, ಅವ್ರದ್ದು ಇಂಪ್ಯಾಕ್ಟ್ ಫ್ಯಾಕ್ಟರ್ಸ್ಗಳು ಚೆನ್ನಾಗಿದೆ ಅಂತ ಆದರೆ ದಯವಿಟ್ಟು ಅವ್ರು ನಮಗೆ ಗೈಡ್ ಮಾಡಿ, ಅವ್ರಿಗೆ ಕೂಡ ಅಂತಾರಾಷ್ಟ್ರೀಯ ಮಟ್ಟದಲ್ಲಿ ಒಂದು ಎಕ್ಸ್ಪೋಜರ್ ಕೊಡಿ. ಜೋಶಿ ಅವ್ರಿಗೆ ಕೇಳ್ಕೊಂಡಿದ್ದೀನಿ, 5 ದಿವಸದ ಈ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ನಮ್ಮ ಟೀಚರ್ಸ್ಗಳಿಗೆ ಅವ್ರ ಜೊತೆಗೆ ಒಂದು ಸರಿ ಕಾಂಟ್ಯಾಕ್ಟ್ ಮಾಡೋಕ್ಕೆ ಒಂದು ಅವಕಾಶ ಮಾಡಿಕೊಡಿ. ಒಂದು ಸಣ್ಣ ಕಾಂಪೋನೆಂಟ್, ಸೊ ದಟ್ ಆ ಯಂಗ್ ಟೀಚರ್ಸ್ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಮೀಟ್ Dr. Nag and then have an interaction and find out what is happening elsewhere. ಅವರು ಮಾತಾಡ್ತಾ ಇದ್ದ ಪ್ರಾಜೆಕ್ಟ್ಗಳನ್ನ ಕೇಳ್ತಾ ಬಂದರೆ ನನಗೆ ತುಂಬ ಖುಷಿ ಆಗುತ್ತೆ. ಇದ್ರ ಜೊತೆಗೆ ನಾನು ನಮ್ಮ ಎಲ್ಲ ಯಂಗ್ಸ್ಟರ್ಸ್ಗಳಿಗೆ ಮತ್ತೊಮ್ಮೆ ವಿಶ್ ಮಾಡ್ತಾ, ಸೈನ್ಸ್ನಲ್ಲಿ ಈಗಾಗಲೇ ನಾವೊಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ, ವಿ ಶುಡ್ ಬಿ ವೆರಿ ಗ್ರೇಟ್ಫುಲ್. ಐ ಡೋಂಟ್ ನೋ ವೆದರ್ ಪ್ರೊಫೆಸರ್ ಜೋಶಿ ಹ್ಯಾಸ್ ಟೋಲ್ಡ್ ಯು, ಡಾಕ್ಟರ್ ನಾಗ್, ನಮ್ಮವರು ಸೋಷಿಯಲ್ ಸೈನ್ಸಸ್ನವರು ಮತ್ತು ಪ್ರೀಮಿಯರ್ ಸೈನ್ಸ್ನವರು ಇವತ್ತು ಒಟ್ಟಿಗೆ ಸೇರಿಕೊಂಡು, ಸೋಷಿಯಲ್ ಸೈನ್ಸ್ ಹ್ಯುಮ್ಯಾನಿಟೀಸ್ ಅವರು ಮತ್ತು ಸೈನ್ಸ್ನವರು ಒಟ್ಟಿಗೆ ಸೇರಿಕೊಂಡು ಬಹಳ ದೊಡ್ಡ ಪ್ರಾಜೆಕ್ಟನ್ನು ತಗೊಂಡಿದ್ದಾರೆ. ನ್ಯೂಕ್ಲಿಯರ್ ಇಂಪ್ಯಾಕ್ಟ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ನನಗೆ ಎಷ್ಟು ಖುಷಿ ಆಗಿದೆ ಅಂದರೆ ಇವತ್ತು ಈ ಯೂನಿವರ್ಸಿಟಿನಲ್ಲಿ ಸೈನ್ಸ್ ಏನು ಅರ್ಥ ಆಗದೆ ಇರ್ಬೋದು ನನಗೆ, ಆದರೆ ಬಹಳ ದೊಡ್ಡ ಒಂದು ಕೊಲಾಬರೇಷನ್ಸ್ ನಡೀತಾ ಇದೆ. ಇಟ್ಸ್ ನಾಟ್ ಬಿಟ್ವೀನ್ ದಿ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ಸ್, ಬಿಟ್ವೀನ್ ದ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಸ್. ಐ ಮಸ್ಟ್ ಟೆಲ್ ಯು, ಇದೆಲ್ಲ ಆಗ್ತಾ ಇದೆ. ಅದು ನಮ್ಮ ಮಕ್ಕಳಿಗೆ ಗೊತ್ತಿದೆಯೋ ಗೊತ್ತಿಲ್ಲ, ನಮ್ಮಲ್ಲಿ ಆ ಥರದೊಂದು ಫೋರ್ಜಿಂಗ್ ರಿಲೇಷನ್ಶಿಪ್ ಅಂತ ಹೊಸ ಅಕಾಡೆಮಿಕ್ ರಿಲೇಷನ್ಶಿಪ್ ಬಗ್ಗೆ ನಾವು NEP-ನಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇದ್ವಿ. ವಿ ಹ್ಯಾವ್ ಸ್ಟಾರ್ಟೆಡ್ ಫೋರ್ಜಿಂಗ್ ಅವರ್ ರಿಲೇಷನ್ಶಿಪ್ ವಿತ್ ಡಿಫ್ರೆಂಟ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಸ್ ವಿಚ್ ಅದರ್ವೈಸ್ ವಾಸ್ ಅ ಸಪರೇಟ್ ಎಂಟಿಟಿ. ಪೊಲಿಟಿಕಲ್ಸ್ ಅಂದರೆ ಬೇರೆ, ಹಿಸ್ಟ್ರಿ ಅಂದರೆ ಬೇರೆ, ಸೋಷಿಯಲ್ ಸೈನ್ಸ್ ಅಂದರೆ ಬೇರೆ ಅಂತ ಗೋಡೆ ಕಟ್ಟಿ ಗೋಡೆ ಬೆಳೆಸ್ತಾ ಇದ್ವಿ. ಈಗ ಗೋಡೆಗಳನ್ನು ಮುರಿತಾ ಇದ್ದೀವಿ. ಬ್ರೇಕಿಂಗ್ ದಿ ಬ್ಯಾರಿಯರ್ಸ್ ಅಂಡ್ ದೆನ್ ಕಮಿಂಗ್ ಟುಗೆದರ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಅಂಡ್ ಸ್ಟಡಿ ವಾಟ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್ ವಿತ್ ನ್ಯೂಕ್ಲಿಯರ್ ಪ್ರಾಜೆಕ್ಟ್ ಟುಡೇ. ಕೈಗಾ ಪ್ರಾಜೆಕ್ಟ್ ಬಗ್ಗೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ನಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗಳು ಅದರದ್ದು ಸೈಂಟಿಫಿಕ್ ಇಶ್ಯೂಸ್ಗಳು ನಿಮ್ಮ ಜೊತೆ ಚರ್ಚೆ ಮಾಡ್ಬೋದು. ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಗಿವ್ ಯು ರಾಂಗ್ ಇನ್ಫಾರ್ಮೇಷನ್, ಸೇಯಿಂಗ್ ರಾಂಗ್ ಥಿಂಗ್ಸ್, ಬಟ್ ದರ್ ಇಸ್ ಅ ವಂಡರ್ಫುಲ್ ಪ್ರಾಜೆಕ್ಟ್ ಗೋಯಿಂಗ್ ಆನ್ ವೇರ್ scientists as well as the humanity professors have engaged in a joint venture. I believe Mangalore University will do a wonderful job here afterwards. ಮಕ್ಕಳೇ, ನೀವು ಕೂಡ ನಮ್ಮ ಎಲ್ಲ ಟೀಚರ್ಸ್ಗಳದ್ದು, ಅಟ್ಲೀಸ್ಟ್ ಟೀಚರ್ಸ್ಗಳದ್ದು ಬೈ ಪಾಠ ಮಾತ್ರ ಅಲ್ಲ, ಎಂತ ಮಾಡ್ತಾರೆ ಅವರು, ಏನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅವರು ಅಂತ ಸ್ವಲ್ಪ ಅವರ ಬಗ್ಗೆ ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ಅವರ ಜೊತೆ ಮಾತಾಡಲಿಕ್ಕೆ ಒಂದು ಅವಕಾಶ ತಗೊಳ್ಳಿ. 1 ಗಂಟೆ ಟೈಮ್ ಕೊಡಿ. ಟೈಮ್ ಟೇಬಲ್ನಲ್ಲಿ ಎಲ್ಲ ನಮ್ಮ ವಂಡರ್ಫುಲ್ ಟೀಚರ್ಸ್ಗಳ ಜೊತೆಗೆ ಇಂಟ್ರಾಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ನಮ್ಮ ಮಕ್ಕಳಿಗೆ, ಅವ್ರಿಗೂ ಕೂಡ ಉತ್ಸಾಹ ಆಗುತ್ತೆ. ಐ ಥ್ಯಾಂಕ್ ಡಾಕ್ಟರ್ ಜೋಶಿ ಫಾರ್ ಗೆಟಿಂಗ್ ಎ ವಂಡರ್ಫುಲ್ ಯಂಗ್ ಮ್ಯಾನ್. ಇಬ್ಬರು ಮೈಸೂರಿನಲ್ಲಿ ಓದ್ದವರಂತೆ ಮತ್ತು ಜೋಶಿದು ಜೂನಿಯರ್ ಅಂತಾರೆ ಅವರು. ಆದರೂ ಯು ಹ್ಯಾವ್ ಡನ್ ಎ ವಂಡರ್ಫುಲ್ ಜಾಬ್ ಡಾಕ್ಟರ್ ನಾಗ್. ನೀವು ನಮ್ಮ ಯೂನಿವರ್ಸಿಟಿಗೆ ಬಂದಿದ್ದು, ನಮ್ಮ ಜೊತೆಗೆ ಇರ್ತಾ ಇರೋದು ಭಾಳ ಖುಷಿ ಆಗುತ್ತೆ. ನಿಮ್ಮನ್ನು ಮತ್ತೊಮ್ಮೆ ಭೇಟಿ ಮಾಡ್ತೀನಿ ನಾನು 5 ದಿವಸದ ಒಳಗಡೆ. ನಮ್ಮ ವಿದ್ಯಾರ್ಥಿ ಸ್ನೇಹಿತರು, ನೀವು ಮತ್ತೆ ಇದಾದ ಮೇಲೆ ಅಲ್ಲಿ ಹೋಗಿ ಎಂಜಾಯ್ ಮಾಡಬೇಕಾಗಿದೆ. ಐ ಆಮ್ ಹ್ಯಾಪಿ ದಟ್ ಯು ಪೀಪಲ್ ಕ್ಯಾನ್ ಸ್ಯಾಕ್ರಿಫೈಸ್ ಫಾರ್ ಯುವರ್ ಸೆಲ್ಫ್ ಈವನ್ ದಿ ಕಲ್ಚರಲ್ ಪ್ರೋಗ್ರಾಮ್ಸ್. ನನ್ನ ಕೊಲೀಗ್ಸ್ಗಳು ತುಂಬ ಜನ ಬಂದಿದ್ದಾರೆ. ತಮ್ಮೆಲ್ಲ ಧನ್ಯವಾದಗಳನ್ನು ಹೇಳಿ ನಾನು ನನಗೆ ಇಲ್ಲಿಗೆ ಕರ್ಕೊಂಡ್ಬಂದು ಡಾಕ್ಟರ್ ನಾಗ್ಗೆ ಪರಿಚಯ ಮಾಡಿಕೊಟ್ಟದಕ್ಕೆ ಜೋಶಿಗೆ ಮತ್ತು ಎಲ್ಲ ತಂಡಕ್ಕೆ ನಾನು ಧನ್ಯವಾದ ಹೇಳಿ ನನ್ನ ಮಾತನ್ನು ಮುಗಿಸ್ತಾನೆ. ಹ್ಯಾವ್ ಅ ವಂಡರ್ಫುಲ್ ಡೇ. ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್.
Thank you, sir. Before we conclude, we must take a moment to express our heartfelt gratitude to everyone who made this event possible. To officially extend our thanks, now I request Dr. Nivedita NB, Faculty, Department of Biochemistry, Mangalore University, to deliver the vote of thanks.
Good morning to one and all. It is indeed an honor and privilege to stand before you today and extend the vote of thanks for the inaugural function of GIAN program. First and foremost, I express my sincere gratitude to our esteemed Honorable Vice Chancellor, Professor P.L. Dharma, for taking time from his busy schedule to grace this occasion and deliver the presidential address. Sir, your encouragement and support serve as a great source of inspiration. On behalf of GIAN program and Biochemistry program, I extend my heartfelt thanks to you, sir. A special note of appreciation to today's distinguished resource person, Dr. Nagaraj Nagatihalli, Assistant Director for Basic Science Research and Associate Professor of Surgery, Pancreatic Cancer Center, Sylvester Pancreatic Cancer Research Institute, University of Miami, USA. Sir, we are truly honored to have you with us. Thank you for sharing your valuable insights, which will surely enrich our understanding and inspire us. I take this opportunity to extend my gratitude to Sri K. Raju Mogavira, KAS, Registrar of Mangalore University, Professor H. Devendrappa, Registrar, and Professor Sangappa, Finance Officer, for their unwavering support and encouragement in all our endeavors, even in their absence today. A heartfelt thank to Professor Chandrasekhar G. Joshi, Coordinator of the Biochemistry Program, and GIAN Course Coordinator, for his relentless efforts in organizing this event. Sir, your dedication and leadership have been instrumental in making this program a reality. I would also like to acknowledge Professor Ganesh Sanjeev, local coordinator of the GIAN program, for his commitment and a contribution in planning this event despite his absence today. I extend my sincere gratitude to the national coordinator of GIAN, IIT Hyderabad, and the Ministry of Education for their invaluable support in finding and facilitating this program. Their contribution have been instrumental in ensuring the smooth execution of this initiative. I extend my thanks to the Dean, Faculty of Science, Director of various centers, Head of the Department, and senior faculty members who have honored us with their presence today. Your support and encouragement means a lot to us. A special mention to Professor G.J. Satish from Department of Biochemistry, Kuvempu University, and Professor Raghavendra H.L. from Pravara College of Medical Science, and Professor Raghu from Kuvempu University for joining us on this occasion. Thank you, sir. To all the participants Your enthusiastic engagement and active participation have made this event truly memorable. Thank you for being part of this program. A heartfelt thanks to the engineering section for their seamless technical support and to the computer session for facilitating the live telecast of this event. I also extend my gratitude to the photographers and media people for capturing and documenting this event. A special word of appreciation to my colleagues, research scholars and our dedicated students for their hard work and commitment in organizing this program. Your teamwork and dedication have been commendable. I would also like to recognize the non-teaching staff whose behind the scenes efforts have played a crucial role in the success of this event. A special thanks to today's Master of Ceremony Ms. Nikita K and Ms. Shravya Naik along with their team for ensuring the smooth and engaging flow of the program. Finally, my deepest appreciation to each and every one of you who has supported us directly or indirectly in making the inaugural function of the GIAN program a grand success. Once again, thank you all for your presence and encouragement. Thank you.
ಆದ್ರೆ ಮತ್ತೆ ಚಳಿ ಶುರು ಹೋಗ್ತದೆ. ಇದಕ್ಕೆ ಕನೆಕ್ಷನ್ ಎಂತ ಮಾಡೋದಿಲ್ಲ ಈಗ, ಇದಕ್ಕೆ ಅಂತ ಕನೆಕ್ಷನ್ ಮಾಡೋದು. ಹಾಗೆ ಅವ್ರು ಆದ್ಮೇಲೆ ಕರ್ಕೊಂಡು ಬರ್ತೀವಿ. the interaction and as well as learning process. Okay, so where maybe you will be sharing the ideas as well as you gain the ideas, and you know what better way we can do the science. So overall idea is this one, and most of you as you are youngsters, you can discuss many aspects with the resource person. He is very friendly, and you will see once he starts interacting with you. So you need not to worry whether you have a small doubt or whether you have that doubt whether it is worthy to ask or anything. You need not to hesitate in any way. Okay. Totally we have 12 lecture series, that is of nearly 1 hour, and along with that even we have tutorials in between. So tutorials are mainly, they are focusing on the interactions, and maybe you can, whatever the doubts you have, because yesterday only I have circulated you what about the tutorial content, what we are going to discuss is today. So you can go through that one. If you have any doubts, you can get it clarified, because basically we are working on how we can use this in vitro and in vivo models, and what way we advance the science using these models. That's what our major goal is. And basically Dr. Nag, he is a meticulous planner, and he has a in-depth knowledge about the cancer, because he has worked on different models of cancer. That's why you will be benefited a lot. And his knowledge to be utilized to the maximum extent, that is with you. How best you use, it is up to you. And moreover, not be uncomfortable with this one, because it is a kind of interactive session, and you can always have a good interaction with him. Suppose if you cannot ask any questions in the session, even in tea time or any leisure time, you can approach him, and not only restrict yourself only to the cancer biology. He has a in-depth knowledge about even writing the grants, collaborative works, because even he has struggled so much to come to that much position. Because yesterday we were discussing about how he was struggling to get a small thing done at Mysore PhD. So you can learn that small tips will help you a lot. When you are doing research, sometimes you think that, oh, this is not working, that is not working. So that time you imagine how much struggle he might have done to reach this maybe the position. So you can get inspired by the thinking. That's what always I like, his way of thinking. Always he is positive about the science, as well as the overall culture, everything. He has a positive attitude towards that one. So you should have certain things which you can take away from this interaction, because 5 days is a very long time. Even he has spent 5 days, means is actually for him it is nearly around 5 months time, because he has to spend that much of time. And you should make use of that one to the 100%. That's what I expect as you, the participants of this program. So out of the 12 lecture series, he will be delivering 10 lectures, maximum chunk he will be covering, and I will be taking only 2 lectures. Basically we are telling about the basic science, what we did in our laboratory, that maybe with the related to this, the in vitro and in vivo model, I will be discussing about that one. So maybe you can focus on what he is telling and what are the aspects to be covered, because every now and then he gives some hint. The way you catch, that is up to you, because each time he throws you some knowledge or some hints, just you have to catch that one. That is up to you, because as I was associated with him, he is full of ideas. So make sure that you are into this one and fully involved in this one, and let us not be restricted only to science. Let us interact with him, and you can discuss all other aspects, how to go to maybe US, some of you are at the verge of completing PhD. You can take all information from him. And moreover, these topics, we will try our level best to complete all the topics which is mentioned in this one. We have put a lot of effort to make sure that everything to be covered in that one. We make sure that we will actually try that our level best to cover all the topics. And the day one session, I have circulated already even the hard copies of this one, it is with you. So this formally we will start with actually the basics of exploring the mechanism of cancer progression and therapeutic response. And he starts with insight into the pancreatic cancer. So there he will be explaining you about maybe the what way the cancers can be approached, and he has his own way of the maybe interacting with you. And along with that, we have mentioned it as problem solving session. This is basically, we want it to be a kind of interactive session rather than one-sided approach, because you have certain knowledge and he has the overall idea about that particular topic. So we gave you a hint what kind of questions you can have an interaction. So it doesn't mean that you should ask that question only. Maybe related one, or whatever you find something which you have not understood, that can be discussed here. And second, after lunch, we will have basics of cancer biology. Those who are not that much familiar with the cancer biology, I think that session will help you a lot, because he is explaining tumor progression and cellular mechanism. Totally it covers almost all the mechanism of cancer, how it should be studied. And then we are actually trying to link the topic one to the other, so that let it move in a smooth fashion. Because if I am taking one topic and the other topic is covered in some other time, you may not get what is actually we are going to convey you. So that's why we have taken that tutorial session as differences in cancer type and studies. There you will have a discussion. And then, because sometimes it should not be a one-sided way of interactions. So we want to know what actually you grasp and what exactly you expect from us. Next day, that is second day, we are going for translational journey from molecular mechanism, early phase of clinical trials. Because whatever he is speaking, already he did all such things, because he practically knows the problems or maybe the bottlenecks of each and every aspect of this the work. So you can interact with him. And the session, you can see that later I will briefly explain about the study, what we did. Later he will start with tutorials again. And lunch, after lunch we are having once again one session where designing cancer model to study cancer progression. Here only actually most of us, we have the problem, what kind of model we have to design, what best way we have to do the research. So in such occasion, better you interact with him, because he knows the conditions of Indian state universities as well as the best labs in the world. So he has a long journey. So that journey will help you even to design your studies when, suppose if you are doing the research or if you are going for the research. So the third day we will slightly go ahead with our own, maybe the topic, where targeting cellular signaling and tumor microenvironment, because nowadays the drugs, they fail because of the modulation in the tumor microenvironment. The cancer cells have their own atmosphere. They may prevent the drug interaction, or they may actually make the drug to enter. So these topics will make you to think in a different way, why or what way we have to target or focus on cancer, maybe if you are working on the drug discovery part. And later on, linked to that one, maybe this is the one where maybe the second talk, what I will be telling is that how maybe the Indian scenario I will come up with, where the bioinformatics as well as the drug discovery together, we did a preliminary study which may help you to go forward with, along with the advanced study what Dr. Nag will be telling you. And later on, the discussion will follow the models to study tumor microenvironment, because you can see that there is a link between the tutorial as well as the topic which is covered, so that you can follow the topic easily. And later on, after lunch, he will tell you about designing therapeutic strategies in cancer research, how to design your therapeutic study, what best way, the overall therapeutic, because it is not limited to the in vitro or in vivo, or even you have to go for clinical trials, that is the phase 1, phase 2 or phase 3. So what may be the things that is associated, he will be explaining about that one. So we will try our level best, because that's what we planned meticulously. This is actually the plan of not one day, it is nearly 1 year. We planned everything. And next is that he will be telling about, because India is rich in all the natural compounds, why we selected that topic. And we have that potential natural drugs with us. What best way we can use that one for the cancer prevention, because even he has worked on various natural products. So what way he approached, what way he did the innovative thing, that he will explain you. And understanding the basics of cell culture, I will be explaining. That is an interactive session. We need not to be too formal, where we will be studying only the basic aspects of science, because with the Indian scenario, we may have certain limitations. In that limitation, what type of work we can do, that let us discuss there. And next is that he will be explaining about in-vivo models in cancer studies. He has worked on various, maybe the cancer models, starting from maybe the regular mouse, what you have seen in the lab, till that GEMS, that is genetically modified animals, as well as knockout mouse or whatnot. He has worked on transgenic mice and all. So he has in-depth knowledge, because he worked on each aspect. He knows what it is. And later on, we will just have a visit to the cell culture lab. Maybe some of you may be new to cell culture lab. We cannot enter directly into cell culture lab, because active work is going on. From the outside, we can see what and all the work is going on. You can observe the cells, or you can see the arrangement of the labs. And along with that, what are the instrument facility Mangalore University has, that you can study. We have NMR, confocal microscopy, as well as even we have a very good nuclear science laboratory, that even you can think about collaborative work, because this, the total concept of this, the workshop is to maybe to enhance the collaborative kind of research. You can find out the ways where you can collaborate the things with the faculty members, or maybe the resource person, everything. And later on the 5th day, so we actually, Professor Satish sir actually helped me to design certain timings actually. He suggested this is the best timing for all the participants, because some of the participants, they are coming from different places and various places. It may take some time. That's why let us stick on to 10 o'clock to start the program. So I thought even that is the best idea, because sometimes if you are stuck in the traffic, so it will be difficult for the participant to reach the program in time. That's why we have made sure that it starts at 10 o'clock. And the last day, because we know that many of you are from the out of this Mangalore city, you may find it inconvenient to reach your place if you don't wind up within time. So that's why we starting this session at 9 o'clock, and by 12:30 we should have our valedictory function, so that maybe by 1:30 you can finish off your lunch, and you can plan your journey accordingly. That's what I communicated you also once I circulated this one. And 9 o'clock he will be explaining about the compound screening. That's what most of us we usually do in cancer biology. And important thing is that he will tell you about even the targets, what should be targeted and what way we have to target the drug. And later we have a examination session. It is not a regular degree examination. Don't be that much serious, but we are supposed to assess you people, because we cannot give the certificate as it is, because 5 days you have learned so much. At least we should know what actually we taught you. So for that one we have a kind of assessment. So the assessment will be based on whatever we teach you here. We don't go beyond that one. So basically it is related with the topics that is covered in this week. And last stage, that's what actually Dr. Nag, he highlighted, because ultimately we have to make sure that overall what happened with these 5 days, that we kept it overall discussion on cancer research, models, therapeutic and interaction session. So the last session will be that one. You can have any kind of discussion, and we are not restricting anything that can be discussed here or in this platform. And I want your active participation, because even the resource person will be happy to interact with you. He has so much knowledge and ideas. So ultimately it is up to you to make use of this one to the maximum extent. Okay. With this, overall I told about you how the program runs. So this is way we have planned, and we made sure that it should help all those who are attending here. And whenever you find time, don't hesitate to interact with the resource person. And if you have any difficulties, let me know. So with this, I think the program will be really helpful for you. You can take the memories of this event, so that your planning of the research will change, and your way of thinking about the cancer biology and the way you think about the research will be a kind of transformed one. I think that will help you a lot. Okay. With this brief introduction, I think I should give a platform to Dr. Nag, because I will be speaking more. So I will request Dr. Anita to introduce Dr. Nag to the gathering again, so that we will have a formal interaction later. Thank you.
Thank you, sir. Distinguished subject expert, Dr. Nagaraj Nagatihalli, and dear participants. It's with immense pleasure and great honor that I extend warm welcome again to all of you to this 1 week GIAN program. And it's my privilege to introduce our distinguished guest, Dr. Nagaraj Nagatihalli, a leading expert in cancer biology and translational medicine. Dr. Nagatihalli currently serves as an associate professor of surgery and graduate faculty in cancer biology at the University of Miami, Miller School of Medicine. He is also an integral member of Sylvester Comprehensive Cancer Center, where he leads groundbreaking research on pancreatic, lung, and oral cancer. Dr. Nagatihalli holds a PhD in biochemistry from DFRL Mysore, following which he pursued his postdoctoral research at the University of Louisville and Vanderbilt University. His academic journey has been marked by a commitment to unraveling the molecular mechanism underlying tumorigenesis, drug resistance, and targeted therapies. Over the years, Dr. Nagatihalli's work has earned numerous national and international recognitions. Some of his most notable honors include Young Investigator Award from the American Pancreatic Association, Stanley Glacier Research Award, University of Miami in 2016, James Esther King Biomedical Research Award from Florida Department of Health, multiple travel scholarships from organizations such as National Pancreas Foundation, the American Association of Cancer Research, and Collaborative Alliance for Pancreatic Education and Research. Dr. Nagatihalli has been highly successful in securing competitive research grants, which includes NIH R01 grants worth rupees $1.7 million, which is around 13 crores in Indian rupees, and Florida Health Research grants worth rupees $0.58 million, again around 4 crores in Indian rupees, and again NIHRO in grants worth rupees $2.48 million, which is equal to 21 crores in Indian rupees. So his research has also contributed to phase 1 and phase 2 trials, clinical trials targeting key pathways in pancreatic cancer research. So Dr. Nagatihalli has published extensively in high impactful journals with over 60 peer-reviewed research articles, 4 book chapters and 127 papers presented in various conferences. He contributed for various editorial boards such as managing editor for Nutrition Journal, associate editor in Frontiers in Gastroenterology, associate editor of Frontiers in Oncology, editorial board member for Journal of Biological Sciences, and many more. He is also reviewer for various national and international research grant proposals. Beyond research, Dr. Nagatihalli is dedicated mentor and educator, having guided over 15 postdoctoral fellows, numerous graduate students, and medical residents. His mentorship has helped shape the next generations of research, many of whom have secured independent faculty positions. Today, we are privileged to hear from Dr. Nagatihalli, who will share his expertise on cancer signaling, network tumor microenvironments, and novel therapeutic strategies. Please join me in extending a warm welcome to Dr. Nagatihalli, Nagaraj Nagatihalli. Sir, the stage is open for your delightful talk.
Hi everyone. Hope you all heard everything. Don't worry about whatever they said. I think important. I think learning whatever Joshi was saying and Ma'am was saying. Um, it's not about knowledge. Knowledge gained by doing it, doing the experiments, conducting experiments, and this knowledge is from the experience. So I'm going to share everything what we have been through many years, and I've been through many years. Just not the pancreatic cancer. I'm a pancreatic cancer, researcher. It's not on. I will on and then I will say. I don't want anything to go like. Um, it's also about lung cancer. I was a postdoctoral working in head and neck cancer, oral cancer, and then I shifted to lung cancer and colon cancer. I was not knowing when I go to United States. You don't know until certain years what exactly you want to do. It takes time. So that we will talk more if you are all interested. Why it takes more time? session is going to be hard for you because I'm going to talk about my cancer research in present pancreatic cancer. I'm not talking about particular normal, what is cancer biology, what is cancer, normal tissue. No, I'm going to start with the research. But also I'll explain to you, because I want to introduce myself, what I am, what I'm doing right now, rather than just telling you or someone is telling you what I have achieved, right? It's more than that. Let's go through the real world and see what you have done, so that I will also in the meantime, I'll tell you the story about the cancer, story about what you can do, what you can learn, and what you can conduct with the facility that you have in your university or your institution in real world. Let's be practical and learn from it, and rather than so many things that I'm going to show you, that with the experience, with the laboratory, what you have conducted research, I'm going to show you. I don't tell you the story about Louis Pasteur or something else or someone else. No, we talk about what we have done, what we can do. That's all. Okay, this next 5 days, there is no history. It's only practical. This is okay, whether you can do it or not. I'll tell you whether you can do it or not. Okay, whatever they have said, it's true, but in a way that most important thing, what they don't know is that what we have been through, what I have been through, right? So that we're going to share, that we're going to discuss, so that you learn from it. You don't have to waste many years. So you can actually straight away just start getting the product out of it, right? If you learn something. But especially this talk, it's okay. If it is a little bit over than what you thought, it's okay. But I'll also explain to you in a way that if you don't understand, it's fine. Okay, don't worry about it. We will, next 4 or 5 days, whatever, I'm going to take one example from here, and I'll explain to you why I presented that, why I showed you the little work that I'm showing you today. And I'll explain again why I want to explain, because as a research, I will show you the whole thing, but when it comes to understanding, I have to explain to you, right? Some research probably you might have not done, or you might have done, probably you might have not noticed, things like that. So that's all. Let's do today. First talk is on pancreatic cancer, but it's a story, okay? The research story. So we, in between, I will explain to you why we have conducted these things, so that you'll learn from it, okay? You turn on and then. So you can hear me, right? Is it too loud? Too loud, right? I don't know how to reduce it. Now it's okay? Now it's better, I think, right? Now it's better? Now it's better, okay, good, thank you. Okay. Okay, once again, thanks to GIAN for this grant. Thanks to Joshi for writing this grant together with me. So, and also Mangalore University for this, the great opportunity, support, especially, the whole Mangalore University team. Once again, I sincerely thank the Vice Chancellor, today's the program, and all the facilities they have given to all the participants, and accommodation and everything, whatever they have done to make sure that you're here. Today is the first day. First talk is all just about the introducing the pancreatic cancer. So as I said before, that I've learned the lung cancer. I've done postdoctoral in lung, head and neck cancer, oral cancer, and researched on lung cancer and the colon cancer. And I went to pancreatic cancer because one time I met a surgeon who was actually a pancreatic cancer researcher. He was not a researcher, he was a surgeon. When I met him, and he was telling me about the story in Vanderbilt University. Vanderbilt University is called
southern Harvard. Means that in America, if you take the southern part of it, okay, Vanderbilt University is considered a south region. In that south region is one of the Ivy League university. So so we called Southern Harvard. That university, I went to that university from Louisville. The reason I went to university, I was passionate to conduct cancer research. So from in Louisville University, my mentor was a German who actually molecular biologist, and I wanted to learn more of translational studies. So I went to Vanderbilt University, joined, and when I met this surgeon, he told me about the pancreatic cancer patient stories. Like people are dying. At that time in 2007, 2008, after my postdoc, I was an instructor at that time, and when he told me the stories, I was like, what? I think we can do research. Then he said, I don't know anyone, so I can do it. We can start the lab. So he was excited to start the lab. He was a surgeon. He had all the ideas about the translational studies. Means that he knows patients, he knows what's going on. What I wanted is that exactly. So I was a cancer biologist. I studied in head and neck cancer. I was studied in lung cancer. At that time I was doing the lung cancer. I never experienced the patient. I was like you all. You're studying the cancer biology, doing some cell cultures, doing some molecular biology, but I don't know where these studies were going. I was not knowing. So, but that is not what I wanted. That's not why I went to America, leaving the DRDO job, right? It's a big thing. So I wanted to really learn cancer biology. So he gave me the opportunity to start the pancreatic cancer lab. I started from scratch with the 2 cell lines, the pancreatic cancer lab, just on one table. There was no sitting table. There was no computer. There was nothing. You think that you have a problem? No, I have a problem too. When I started in 2007, there was no computer because we didn't have money. But only we had is a passion. We had the university name tagline, right? That's enough. When you have a university name like Mangalore University or Bangalore University or Coimbatore University, you have a tagline, Coimbatore University. So you take the tagline, doesn't matter where you are living, important is that where you are from. I'm from Vanderbilt University. Oh, then Vanderbilt University, oh, okay, there are people recognize that university. Okay, that means that I can collaborate and I can interact and I can get it done. There are many ways that we can interact and talk about it later on. Pancreatic cancer is one of the top 10 most common cancers. It's very aggressive, and in terms of mortality, it's ranking just behind the lung and colon cancer. Despite it's a tough disease, survival rates have improved from 5% to 13%, as I told you before, giving us more hope. However, there are challenges remain in this study. Because it's a late diagnosis and also less effective treatments. In pancreatic cancer, always a patient come to a clinic, they're all already late. Okay, because they won't know. It's a very small organ. It's hard to know that you have a pancreatic cancer or not, right? So that's why it's called late diagnosis. They're already dying, almost. Right? And also there is no effective treatment. Pancreatic cancer, the reason I joined the pancreas group, the reason there was no treatment at that time. Many people died. Many people died during that time. Now there is a hope. By 2030, it's expected to be the second leading cancer death. It means that there are more people dying by 2030. That means the expectation, the way that it is going, there are more people are dying. We will talk about why later on, right? And the survival chances vary depending on how early the cancer is found, with the rates dropping as low as 3% in advanced stages. Means that when you take different stages of pancreatic cancer, when you go to the advanced stage, there are more people. There is, survival rate is very, very low because they'll definitely die. They know that. When the patient comes to a clinic, already they know, the doctor knows, they're not going to survive. This patient is going to die. But if you take a lung cancer and the breast cancer and the prostate cancer and a lot of other cancer, people survive completely 100%. Breast cancer, 100% they can survive. So because the treatment advanced, the reason it is advanced because they poured a lot of money A lot of researchers went into the study breast cancer long ago. Lung cancer also the same way. Big people can survive, right? So it's the same way. The pancreatic cancer at that time, there was no money, there was no researchers, there was no investment. So people were dying. So then the government has to fund, the government has to put money. It's the same thing here. The cancer is increasing. The government is now awakened. Government is actually telling, you can see that the present government is actually putting more, interest in cancer research. Okay, the survival rate, chances are vary. As I said, in advanced stages, 3%. Despite these challenges, there is ongoing research, new studies, especially early detection. They have started early detection in pancreatic cancer. Now we have some hope. There is a blood test you can do, and there is already we can see the improving in survival in pancreatic cancer because of the investment they are putting. So my lab focuses on 3 major areas in pancreatic cancer hallmarks. One, there is over 90% of these tumors have KRAS mutations. The pancreatic cancer have more than 90% is KRAS mutation. We talk about these mutations in a while. Today and in next 4-5 days, we keep talking about KRAS, P53, SMAD4, all these mutations. You also know from the from a doctor, oh yeah, this patient has a mutation, this has this mutation, EGFR or whatever they call it. But another thing that you need to know, each cancer have a different mutations, a different problem, right? You have breast cancer, different problem, lung cancer, different problem. But that's why we have to understand each cancer. You cannot jump because there is a money from pancreatic cancer to oral cancer or lung cancer. But if you want to study one cancer, you have to study in depth, in detail, understand the biology before you treat. That's what I was saying. Understand the biology before you treat. And our previous studies have shown that desmoplasia, that is called stroma, is a big barrier in effective drug delivery. We are exploring ways how to overcome this barrier. The problem in the pancreatic cancer is one of the hard tumor. Hard tumor means that any drug you give it to the patient, that is not going to the pancreatic tumor. It's going somewhere else, but not, because it's very hard, because there is a lot of stroma in it. It means that fibrous, it's a fibrous tissue. It's a hard tumor. Pancreas, if you actually see, very delicate organ. But when it comes to tumor, it's a very hard tumor. That's why it's challenging for the doctor, for the researchers to study pancreatic cancer, right? And there is another one, we have established a few studies to show how these tumors weaken the immune system, help themselves grow. Remember, earlier we used to talk about just the pancreas cells, pancreas, intrinsic signaling. We always talk about this signaling, that signaling in the pancreatic cell, in one cell. Now there are so many cells. We understand that as we research increasing, we understand now T cells, fibroblast cells, stromal cells, calf cells, you name it. There is another week, the next day probably there is one more cell will come. You keep on researching, there is one more cells will come. You get confused, but what do I do? Don't get confused. Study what you think is important according to you. It's all important, okay? So don't worry about what others are doing. It's okay. But think within your knowledge what you can do, how you can establish. I was talking about immune system, immunology, immune cells. Very important now. Everybody talks about immunology. Everybody talks about immune cells. Studying is also, technologies are coming, and it's hard to study because there are so many technologies. Which one to use? But in your facility, in your university, again I'm coming, in your research, it doesn't matter. If you want to study something, right, you can always study. It's not hard at all. You want to study immunology, you can study with immunology without any technology. But important is that you need to awaken, you need to have a confidence within you that start doing something. You will find out one day why you cannot, right? You have to start somewhere, okay? That's important. You have to start. There is always a problem for everything, but you have to start, okay? Today, I'll show you our research work in these three specific areas of pancreatic cancer, right? Finding and targeting new cancer-causing factors. It is a risk factors. We can talk about tobacco, alcohol, KRAS, P53. We all talk about, okay, well, there are questionnaires I have given. So we talk about Indian scenario. What are the factors? Is one of the factors is tobacco is increasing here, right? When compared to Western culture. Alcohol. Can you imagine how much people are drinking now? It's too much, right? I mean, it's increasing. When compared to, you go back to 5 years and 10 years, now people are like, everybody's drinking, right? So we have to talk about that aspects too. And in a while, then I'll start talking about alcohol. Increasing drug delivery by remodeling the stroma. We also study how to remodel the stroma. How do we, first you have to understand the stroma. What is stroma? Why stroma is coming, how it is coming, and then we have to target the stroma. Target means what? Can we kill the stroma, or can we just disturb and just let we go? Like for example, there are many people crowded, but you still pass through. But how do you pass through? We say, excuse me, excuse me, excuse me, you just pass through, right? So we have to make some drug which actually says, excuse me, so that the drug will go through. You know what I'm saying? We need the drug which actually can go through that, problem, right? So we have to find, how do we find the drug? That's what I think we are looking into. We are looking into, I'm not telling you in detail exactly how we are looking into, but you have to, exactly as Vice Chancellor was saying, you have to interact with other department, understand the physics, understand something else, chemistry, or some technology, or some different model system, right? Then only you can actually find a way how to make this drug enter through that stroma, enter through that hard core area, right? Also, overcoming therapeutic resistance by modulating immune system. So everybody was talking about, hey, this is a cancer cell, and we can target. Now I'm going to start thinking about immune cells. Why can't I start doing something to do immune cells so that immune cells can take care of the resistance of the drug? You know what I'm saying? There may be immune cells, because people don't know. We all think that, oh, probably I'm starting a research. I'm starting to understand the cancer biology. I'm maybe already everything is done. Maybe I'm actually, I don't know what to do, because everything looks like everything has been done. I don't think I understand this. Yes, everything is done, but still you can do something. Okay? Still you can do something. But you should not worry, oh, everything is done, so you don't have anything else to do. No. There is always a way if you want to do, right? So we found immune cells, immune microenvironment, and then we targeted immune environment. Then we saw, oh my God, why we didn't learn this like 10 years ago? We would have treated this patient much better, right? That is the knowledge, right? Somebody says, oh, virology, no, I don't want to do virology. Maybe you may have to do virology. You never know. I don't want to do bacteria. No, you may have to do bacteria. There's a good bacteria, bad bacteria. Okay? What bad bacteria do and good bacteria do, right? Then if you can understand and differentiate this, then you can find what is your problem in your research, whether you want the good bacteria or the bad bacteria. Then how these bad bacteria work and the good bacteria work? Like this. Start thinking and converse with your colleague, and maybe one day you'll find it. It's not big deal. You all find something new, right? So during the progression of pancreatic cancer, several key biological events mark this aggressiveness, right? So one is the acinar cells undergo reprogramming into a ductal-like structure due to inflammatory signal and initiate the precancerous pancreatic neoplasia cells, and which leading to pancreatic cancer. Don't worry. Something that I'm giving you, you may not know. Don't worry. Every cancer starts with, like this is acinar cells here. In the pancreatic cancer, it is acinar cells. In the breast cancer, something else. Colon cancer, something else. But everything has to start from there. And then it will lead to somewhere here. Every cancer lead to somewhere in the middle. But we call it different name. Okay? And then it will go to a cancer we call breast cancer, lung cancer, colon cancer. But it has, the technology, the knowledge you're going to gain, it doesn't matter which cancer, it's all same. Okay, it's all the same process. Only thing, I talk about KRAS today, right now. Probably when you take a colon cancer, you talk about SMAD4 mutation. You take a breast cancer, you talk about ERB. Okay, that's all the difference. But you can do any cancer, doesn't matter what. You're interested in the breast prostate cancer, you can do it. But we call differently. We understand the biology almost same. But there are some cancers, biology is same. There are some cancer, biology is different. But to find out, okay, you need to have some interaction, some knowledge, and also interact with other cancer people. Okay, then you learn something else. Oh, in this cancer, the one now I'm doing, maybe it is not the same way. Or maybe it's the same way. We all understand, oh, okay, what do the stem cells do in your cancer? Oh, stem cells do in my cancer this. Maybe in my cancer it doesn't do that way. So these are all the understanding, these are all the biology. That's what I'm trying to tell you. Okay? And over 90% of pancreatic cancers have KRAS mutation. Over 90%. Okay, KRAS mutation is ultimate in pancreatic cancer, but it is not true in other cancer. In lung cancer, it's only 40-45. So in different cancer, different things. Remember, that's why I was telling you, each cancer is different. Biology kind of same, but if you can understand one cancer, you can start thinking about other cancer the same way. Philosophy is same, but the knowledge, the gain in each cancer, mutation, other factors involved, they're also different. Smoking affects lung cancer more than other cancer, but it also affects prostate cancer, it also affects pancreatic, it also affects brain, it also affects colon, but in a different level. But it does. It's that way I'm talking about. It can affect a lot of organs, but it affects some organs more, some organs less. You may say, again I'm coming, okay, I'm smoking from last 25 years, I don't have any cancer. Yes, sir, you don't have any cancer. But your friend or someone whom you know, he smoked maybe 3 years, but he got cancer. Why? Because there are mutations. Okay, that's what I'm going to talk about that in a while, that there are some mutations in his body or her body that is not there in your body, or your factors, your body metabolic or rate or metabolism or gene system is entirely different than her or his body. That's why you're not getting it, but that person is getting it. How do you know? You don't know. You better don't do it rather than going ahead and then worrying about. Alcohol is the same way. I'm going to tell you the story about alcohol. Oh, I'm drinking so many years. My dad, if he don't drink alcohol, he's not going to be a human being. He has to drink. Okay, nothing happens to him. He was like, he was drinking 95 years, he's fine. He's fine. But you will not be fine. You never know your body system what it is until unless it happens to you, right? It's that way. So around 50 to 75% of pancreatic cancer have a P53 mutation. This is another mutation. We talk about these things tomorrow or later today, a little more in detail, but at least I'm giving you a kind of hint for you guys what's coming so that you'll understand, right? That this KRAS and the P53 mutations are key drivers of pancreatic cancer. The same way, different cancers have different drivers, and they have a different way of doing things, that way. From these studies, we understood that KRAS and P53 are key drivers in pancreatic cancer. Inflammation supports their oncogenic impact. What does that mean? For example, you have a mutation, you have inflammation. Bad. Inflammation to your body is a bad thing. That's why we say, oh, you drink green tea, everything will be fine. Okay, yes, you're right. You take turmeric, everything will be fine. You know what? They are all anti-inflammatory agents. Your body, if you have any inflammation in your body, anti-inflammatory agents always helps, always do good thing. Okay, that's why we don't get stomach cancer much, because we always take turmeric. Turmeric is one of the anti-inflammatory, well known in the whole world. We Indians have done a patent and everything, right? And in the same way in the Chinese green tea, it's the same thing, same concept. But they do drink. When you go to doctor, if anything happens to you, if you go like, I have an allergy problem, doctor says, hey, you should, okay, you can do the allergy test, but you should not drink green tea, you should not take turmeric, you should not take this, because they're all anti-inflammatory. Okay, that's how you know that they're all anti-inflammatory. It can, help you. So, but can coffee do the thing? No. Coffee is not anti-inflammatory. So, it's just that. Okay, if you drink coffee, too much of coffee, what happens? I don't know, you're damaging something somewhere. Maybe less is better, right? Like that. The molecular analysis of pancreatic intraepithelial neoplasia, that means that pannins we say here, this is a normal cell, and the pannin 1, 2, 3, and then the cancer. And this is in pancreas. The same way you go take a breast cancer, you take a lung cancer, same biology, but but naming is different. Here pannin, they are different, something else, the same thing. But in the progression, in the pancreatic cancer, it starts from normal cells to a pannin. It's an early neoplasia. The cells looks like that, and then it will go to pannin 2. Then the cells looks like that, and then the pannin 3. We know that what happens to pannin 3, and I can go in detail if you want to learn pancreatic cancer. I can tell you hours and hours, but that's not important today, right? Important is that this can happen. How do we study? What is the model? I think that we stick on to that. And when it comes to cancer, there are no, these type cells are all gone. This has become completely stroma. Now all the cancer cells are gone. Even the normal cell ductal cells are gone. You know why? Because there is no room. There is like, all the bad things are coming in. The stroma is a bad thing. It's all coming in. That's why the pancreatic cancer will become a hard tumor, very hard tumor, because there are no cells. If you have a cells, there's your tumors are very, delicate and not stiffen. But once the stroma comes in, it's a hard tumor. Okay? In a mouse model, we studied that, this is in the pancreatic cancer mouse model, when we say KC, is a KRAS only. There's only KRAS mutation. We developed this mouse model. Don't worry about this mouse model. Each mouse model, when we talk about mouse model, right, we call, in the pancreatic cancer, we say CRE, specific to the pancreas, we say PTF1A CRE or PDX1A CRE. The same way, don't worry about those names. But what I'm trying to tell you is that if I want to study lung, I have a CRE mice specific to lung cells. We know where to target lung cells. Each cell is a different type. Okay, they all look the same. They all functionally same, but they are different in some certain things. Right? That's how this scientists have investigated some markers so that these are all lung, these are all colon, these are all CRE targeted to colon, CRE targeted to pancreas. So that way we have targeted CRE. This is PTF1A CRE or the PDX1A CRE. So only we tag that to the pancreas, and then we add something else. Like for example, we add KRAS mutant cells, mutant mice, or P53 mutation suppressor gene. We add it to that and study. So if you have these genes here, like an activated or suppressed, now whether this mice makes a tumor or not. The same way, you take breast, lung, colon, anything, doesn't matter what. Study the same way, same concept, same idea. Everybody studies the same way. But as I said, biology is same. There are some markers different. Mutation is different. The way we make them model is all technologically it's the same thing. Okay? But in here, in the pancreas, we have a KC means KRAS mutation. KPC means that KRAS and also P53 mutation. So in the KC, if you see, there are some ductal cells here. Ductal cells means that next stage of cancer. But this KC, if you have a KRAS mutation, it doesn't make cancer. Okay? But when you add a P53 mutation here, it makes cancer. Okay? So, sir, I have a KRAS mutation, I checked. However, I don't know how you checked, but I checked. Do I get cancer? Maybe not. I'm smoking, you may get it. I'm drinking, you may get it. But if you don't have any other problem, just you have a KRAS mutation, people live with KRAS mutation lifelong. if you are taking a good diet, good food, if you don't have any other bad habits, right? I'm going to tell you the story right now, okay? So KRAS mutations activate key signaling pathways such as PA3 kinase, ERK, P38, STAT3, and mTOR. These are the signaling pathways that I'm talking about, which we worked in our laboratory. There are many signaling pathways I'm not talking about, okay? But I'm just giving you a hint on the idea, that's all, right? There may be other pathways too. People have worked on ERK pathway. There are a lot of different EGFR, GPCR of signaling. You guys may be working on some other signaling pathway. So there are many pathways, but these are the pathway in our laboratory we worked on. The reason we worked on, just a second. Hello? 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 So do you know where is he? Hello? 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 I just want to make sure that I'm recording, otherwise they may ask me to talk again. Hello? Sorry about that, guys. So just want to make sure. Okay, I think we will continue. I was talking about the signaling pathway. These pathways are prime targets for the therapeutic intervention in pancreatic cancer. So it's also well established in the field that persistent acute or chronic inflammation together with the KRAS mutation significantly increases the cancer risk, particularly with the inflammatory pancreatic tumors known for this aggressive nature. So I'm going to show you here with the KRAS mutation. I just mentioned about KRAS mutation, remember? With the ACNR cells, there were KRAS mutations here. And now you add the inflammation here, it can lead to cancer, right? So this is kind of, other people have, investigators have studied this, but in different way, differently. Not working. It's not working. Hello. 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 Hello, hello.
Hello, 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 hello. Hello, 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 hello. Check, 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 check. Check, check, check. Check, 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 check. Hello, 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 hello. Hello, hello.
Okay. Split. Why? Okay. But you can't move. Huh? You can't move. No, I'm not moving. Yeah, it should be fine. Hello, hello. Yeah, that's fine. I'm not moving around, so I don't think we need that. Huh? Hello, hello, hello. Yeah, fine. So I was talking about the acinar to ductal metaplasia. So acinar cells to ADM, that means that acinar cells will convert into a ductal type. Like you see, the shape of the cells from here to here different, right? That's how the shape of the cells changes. We say ductal type. And then the shape of the cells change again. It will become something a cuboidal kind of. So it's called pancreatic intraepithelial cells. And then the shape from here to here changes to kind of entirely different. These cells are very aggressive cells. They divide faster. They increase the cell number so fast. So the reason is they mutated. They got mutated during this process. These cells got mutated. There are a lot of mutation, there are a lot of other things, maybe inflammation, maybe something else is happening to these cells. That's why they're changing, right? That's why. So the question is here that without the inflammation, without this inflammation, whether this acinar cells with just the KRAS mutation, can this become cancer? No. So far, whoever did the model, and doesn't matter what type of model they have done, they have not seen it is becoming cancer, right? Something else has to happen. Something else has to come to your body. So it can be from the food, it can be from the mutation, it can be from some other inflammation. Something has to happen, then only it will become. So this has been proved by many scientists in many models. It doesn't matter which cancer, it's the same story. But remember, again, the KRAS I'm studying and showing in pancreas that the same thing is different. Same methodology, maybe mutation is a different mutation in different cancer. Methodology, the idea is all same. The idea, whether these cells will become cancer, the story is the same thing. Okay? So the progression from the pre-malignant, or we can say acinar cells in the pancreas, conditions to cancer remains incompletely understood. Even though we think always, oh, we understood the story, always something else will come in. Someone will say, no, we have this type of cells, we should study, because we saw in this type of cells, there is always, all people, scientists wanted to investigate something new. Everybody wants something new, right? Even the grant you write, they always say, okay, what is the novelty? When you send a paper, they'll say, what is the novelty? Because the novelty, they're asking you to investigate something new. We already know this. What is that you're going to do? What is that you're going to found out? You say someday you're sitting there and you're seeing the cells and you're seeing something, patient tissue or anything. You're seeing something, but you saw something. It may be contamination, but you saw something. And then you start discussing with your colleague, oh, I saw something. Many times in our experience, nothing has happened. It's a contamination. It's something wrong that I have done, or someone else has done, or someone else has poured something or done something. But it's the curiosity that you develop to know what happened is what I think is going to take you to the next level, right? You have to develop the curiosity. It doesn't matter what. Doesn't matter what, whether you're doing the research, whether you're doing something else, or teaching, or you running the bullock cart, whatever. But you have to have that curiosity in your work. Then only you can do something in your life, right? It's the same thing here. The cancer biology studying, you have to develop curiosity, especially when you're doing the research. The curiosity is the ultimate for doing this, okay? And I'm just showing the critical knowledge gap in the pancreatic cancer is understanding the basic biology of it. It doesn't matter how many years we are studying. I said I entered in 2007, I'm still studying. There are a lot of gap, a lot of things that we think, we know, we don't know, right? And we think that we are almost there, we are not there. So this happens. That's why we want more people to study. That's why government is spending more money. But you have to find out something new, unique, your own, and always studying, understanding, and discussing with your other friends and the scientists from different universities, some pioneer, some small things, some small hit can change the way you think, how you want to do research or study or teach. Teaching also. If you want to become a teacher, one hit from someone or something, they say, can change the teaching also same way. So the concepts are same, but the design that you're going to do is different. Okay, we published a paper on alcoholic pancreatitis. Okay, so alcoholic pancreatitis means that you drink alcohol, binge drinking we can say, or completely every day you drink, and there'll be too much of drinking. And there is a high risk in India also, pancreatitis, pain in the pancreas. They go to hospital, emergency, pain in the pancreas. Some people will have a lot of pain and they die because they cannot resist, because they don't have a hospital around, they die. But like in a village side, someone is drinking too much, they die with the pain. Okay, they have too much of pain, they drink more. But they know that it's because of alcohol they're getting the pain, but they keep drinking and they get more pain. But the pain is not going to go away, but actually their brain is going away. That's why they think that the pain is still there in the pancreas. But in where the hospitals are in emergency, people go and get the treatment. All they give is steroids and stuff, because the pain is hard in pancreas. Pain is really hard. Pain is bad in pancreas, pancreatitis pain. Okay, alcoholic pancreatitis is one of the worst thing. Okay, so we developed the model to study alcohol. When the important thing is this: why we studied alcoholic pancreatitis, right? You may be asking, okay, maybe he's interested in alcohol, that's why he's studying. No, of course I'm interested in alcohol study, but more important than that is that one day I was actually, one of my surgeon was telling me that, I see these patients, they have a pancreatitis pain. They all come to hospital, but I don't see any pancreatic cancer in these patients. They all be fine. They give some steroids and other drug, and they all be fine. But I asked him, okay, if they have a pain in the pancreatitis, if they keep getting the pain, they keep drinking, what will happen? Is that anything changes, mutation or anything happens to this patient if they keep drinking so much? And whether they become, any cancer patient have a pancreatitis also? Then he said, there are like 2-3% of patients that come to hospital, it is increasing, and they do have cancer. Means that when we took out the patient tissue, pancreas tumor, because when the pancreatitis is happening, the doctor cannot take the pancreas out. Okay? They only treat with externally. But if you have a cancer, they can treat. They can open they can take the tissue out. But those tissues, in the side by side, you add a pancreatitis and also pancreatic cancer. That means that these patients had pancreatitis, inflammation, that means, and also pancreatic cancer, means that this patient had a pancreatitis. That means, for me, it was curiosity, is that, okay, why, how? To study that, I started studying that you cannot just jump onto something and study everything. Remember, it's a research. You have to study slowly. It takes years. You have to cool down and calm and patience. You have to more patience in research. So we have to study first what happens to just the alcohol. Then you study the model. You make the model. Then you study. And then go to slowly, next. And one day you study everything, right? So this is how we did. We studied just the alcohol. Okay, if you give these mice a lot of alcohol every day, and what happens? They enjoyed it. After a while, we saw what is the problem. And remember, there's a curious thing in this study. You will know soon that when we give the alcohol, these mice, after a while, had inflammation, it came back. You leave don't give the alcohol, they come back. Means that they're all fine. And they have inflammation, they're all fine afterwards. Means that if you continuously drink, there is a problem. But if you stop and again start, it's okay. According to the model, I'm not saying that you have to do that. What I'm saying is that according to our model, it's true that it can recover back. Means any cells in our body, it doesn't matter which cell, breast cells or the lung cells or brain cells or the prostate, any cells, right? They have a recovery stage. They can recover, doesn't matter what damage. That's how the beauty of our body. It can recover any damage. But certain stage, after it reaches one stage, that actually damage occurring every time episode is happening and again, probably not, right? I'm going to tell you that story also. Then we developed the curiosity. The next, we published that, the alcohol pancreatitis model, and we studied and we targeted. There is a story, I'll tell you not today, and I think tomorrow or day after, the whole story of that in a different way. But for us, the curiosity is that, okay, now in this model, I'm going to add KRAS mutation to these mice. What happens? Whether they develop cancer or not. That's a curiosity for us, right? Then, before that, we have to understand the biology. Okay, what happens to this? Okay, go ahead. Completely. Okay. No. So we'll talk about that, our ROS. We can say reactive oxygen species, how it works, and we can talk more and more. But you can completely stop it. Nothing will, it will recover back. So, but remember, it all depends on the damage, how much damage you have, or damage occurred to the body, right? It's about that. We'll talk about that more in detail. Okay, the studies have shown that pancreatic acinar cells can de-differentiate into duct-like states with injury or activation of this KRAS. With inflammation, further it drives to driving this process. So the acinar cells are ductal shape, but with the KRAS mutation, it actually forms this ductal shape. These de-differentiated cells can revert back, okay, to acinar cells after injury resolves. Means that you just leave it, no alcohol, it can actually reverse it back. It's not just the alcohol I'm talking. I'm just giving you one of the thing is alcohol, but it can be any inflammation. Okay, it can be from diet, it can be from the bacteria, it can be from something viral inflammation. It's the same thing. Inflammation is the same thing. So I'm just giving you one external risk factor I'm giving you, right? these de-differentiated cells can go back to SNR cells if you don't have a KRAS mutation, right? If you have a KRAS mutation, it will actually further goes further. So to study this, what we did, we did that cell specific, that is a PTF1A CRE mice specific to these SNR cells, we call CRE. We developed this mice model, and with and without the activated KRAS KRAS in this mice. So we use this PTF1A CRE mice without the KRAS mutation as a baseline model. We developed first baseline model, and we studied, and whatever story item I was telling you, we actually modeled that story to study further, make sure this is how it is happening. And we developed the in vivo alcoholic chronic pancreatitis model by giving the 5% ethanol. It's a diet, it's a liquid diet. It's exactly, the NIH made a rule exactly how we have to treat these mice and give these mice alcohol. And in any study you do, you have to have a standardized way of doing the research according to whatever the rules and regulations, right? And the mice have more rules than human being. They can take the human being and put it in a emergency, or you can cut and open and everything. Mice, we cannot. We have to have the protocol. We have to have the approved protocol from so many organizations, making sure that killing these mice is not affecting something. So, but we can kill human being, but we cannot kill mice. So this is the rule. This is the rule everywhere. For us, the problem is, even though I have to kill one mice, I have to go through so many procedures. But patients, they can die and they can cut open. It's much easier. That's how the world is. So after we studied this histology, the whole thing histology. We don't worry about the details of histology. What we did, what markers and all. When you are studying the cancer, then you will understand that based on what cancer you are studying, what markers to study. Those kind of things you will understand when you are doing the modeling. So here, in the 3-day recovery, is just the 3-day. Means that you hit with alcohol, 2 to 3 weeks of alcohol and continuous alcohol, and after that you stop, right? And within 1 or 2 to 3 days, it will be, you see a lot of fibrosis, a lot of some of these ductal cells and the CK19 and all. But after 21 days, just you will leave it up to 21 days, everything reverses back, just like normal. Nothing happened, as if like nothing has happened to these mice. Okay, it reverses back. So this is just showing the basic model. So also, we as researchers, we are curious, right? Just to understand more biology of it. So now I'm more curious how this is happening. That's the curiosity you develop. And this ductal type of cells, this is the 3-day. We saw here, you see the red one, red is a CK19, that is a marker for the ductal cells. We saw all these red one on the SNR cells. Look how beautifully this went back, all gone by 21 day. So that curiosity, right? Now you'll be even more curious. After seeing this, we are more curious. Okay, then what is biology within those cells type? Means what signaling is activated, what signaling is going away. You're more interested, curious to know even more and more. That's how you'll never go back and eat. The reason is that, okay, you ask postdoc, okay, how do we do next? How do we do? What do we do? How do these signals work? And what signals activated here and deactivated again? Those curiosity. So so next we as previously mentioned, we developed the KRAS mutant mice. Okay, we with SNR specific CRE is actually developed the SNR to ductal reprogramming with this in the model. So this ACP induction in KC mice, in the KC mice, I'm talking about KRAS mutant mice with the alcohol. That is, ACP means alcohol induced KC mice. We saw tumor. You see the tumor here. This is the pancreas, completely pancreas, and we saw the tumor. And we were curious at that time to develop more mice and to study more in depth and understand the biology of it, right?
And then we went ahead and did in the KRAS model. This is the KRAS model, like the same model I showed you without the KRAS. Now you see the KRAS. What happened here? In the 3-day, we stopped everything. We gave 3 weeks of alcohol, and we stopped. Inflammation is happened, and now which has a KRAS. Now you see all the tumor cells are coming out. Means that when you have a KRAS, the ductal cells are all not going back, not reversing, it's continuing. And you see more of ACNR cell, Alcian blue stains for all the, ACNR, ductal cells. And there is a lot of fibrous. And if you see the histology, you see a lot of cancer. We measure all those things, and then we analyzed here. You see a lot of cancer within 21 days. These are all PAN is also kind of a cancer. Okay. Is overall the KC mice with the alcohol, inflammation induced, accelerated this PANIN and cancer development. So this is just to show that we compared this without KRAS and with KRAS, and without KRAS with CP means that just the inflammation, no alcohol. Just I want to have just inflammation, no alcohol. Okay, it's a drug-induced inflammation, no alcohol. When compared to just alcohol adding to the inflammation is even bad. I told you just now that these people keep drinking and they stop, again drink, but even though there is a pain, they keep drinking, even they think that the pain will go away. Exactly what the model is here. They have inflammation and they keep drinking, adding alcohol actually is worsening. They won't know. Your body cannot see inside, only you see outside. Right? Inside what's happening, only you can feel it. You cannot see it. Right? And unless you use the technology. Now we have a technology. So in the KRAS mutant mice, same thing if you compare, same age group, same everything, all these mice, now you see the lot of tumor in the KRAS mutant one. This was very interesting for us, but as a biologist, you know what I'm saying? What are you going to do? I want to know more. Because that is the thing. I want to know more. So to know more, what are we going to do? We do single cell sequencing. You know what is single cell sequencing? You will know more next upcoming days or even later on that just a cell, one tumor cell is not enough today. You have to understand different cell types, how they work, how they interact each other, how they communicate each other. Okay? For example, each B cells, T cells, ductal cells, CAF cells, and neutrophils, and all these macrophages. You have to understand all these cells. That's why you do the single cell sequencing, so that you will know all these cells types. And then what we saw here, we analyzed all these numbers, ACNR cells, control cells with the ACP. You see ACNR cells are going down, and in the ductal cells are going up. What does that mean? Means that ductal cells are increasing. Means that cancer cells are coming out, and ACNR cells are going away, normal cells are going away. If you don't have a normal cells in your body, if any damage happens, you will not be able to recover. We all know. That's why when you get aged, your inflammation, it's very hard to control, right? We all have our grandparents and all. When they have inflammation and everything, it's very hard. Because these cells, they don't have a normal cells anymore. They're all aged cells. So these cells cannot recover these things. That's why we have to take care of them better, right? Because they don't have those normal cells. We have a normal cells. Our kids can break it. They break the leg, they come back. They break the finger, they come back because the cells are so strong. They only have a normal cell. They don't have any other dirty cells, right? But as we middle age, we have a problem. Recovery is a little bit slow. As we get older, it's slow. It's exactly the same thing here. Now you're drinking alcohol and you're reducing your normal cells. You're reducing your normal cells. If you get infected with something else, contamination of something else, like someone is drinking alcohol and he is maybe having a pesticide somewhere. Just imagine the problem to this person. Something might happen, right? So something like that. So it's just a thought
So these are all the biology. I just don't want to go in detail of this, and the person who studied those, technology. See, each technology I'm going to show, there is a person who actually do in the laboratory, or in the neighbor laboratory, or the friend laboratory, colleagues in different departments, and they conduct those experiments and give it to us. So it's an interactive program. Doesn't matter what. When you're studying, you have to have your colleagues. You cannot close your door and study biology today. So you have to have the technology, and you're not yourself. You will not be a scientist. You are binding to other people to conduct those other experiments. So you need more friends today. So here I want to show you these confocal images. I'm going to show you. I'm showing you here is that this is a 3-day. Okay, this is a 21 day in a KRAS mutant mice. What you're seeing here is that beautifully, okay, in these mice, that the green is going away and the red is coming back. Means that the ACNR cells are going away slowly. You can see some cells are going away, some cells are off, some cells are completely clean ACNR, but some cells are completely ductal, right? They are all changing. I'm not lying, this is true. This is exactly what you need to understand. It's a curiosity again. Our curiosity is going, see, when you see it, it is there. You have to investigate. When you see it, don't leave it. There is something. Always go back and study. There is always something. But how you develop that curiosity in your hand. It's in your hand. It's all about your time and your effort. If you have time, if you are interested, it will happen. If you are not interested, it will not happen. So the same way, we went back and you know what? I'm not going to stop this. I want to understand this more and more, how this is happening, why this is happening. I want to know beautifully. One picture can tell you the story. Same thing if I put in a blot here, people can make it. But you know what picture? I cannot make it. You know what I'm saying? So this is happening picture. That's why in my study, more of picture you see because I want to know what is happening rather than just giving a data. I'm not curious. I want to know. In my eye, I want to see it. Okay? Single cell, I see it. I see T cells, what's happening. I see B cells, I am curious. If you take the spatial genomics today, it's happening. You know what? The genomics, when you are spatial genomics, it just takes the area which you select, and you tell them based on the histology, based on the many factors, markers you study, and you tell the technologies, okay, you pick this area and tell me what genes are changing here. I want to know. Then they will give you. That's why this technology is so beautiful. But if you cannot do it, it's also beautiful. You know what? How much ever you can. You don't have to crack your head, okay, I don't have a genomic study, I will stop my research. No. You will never stop research. You have to keep doing the research, but whatever you can do, right? That way. This is one thing. So another way we wanted to know, in just a simple qPCR analysis, taking all these genes, ACNR genes and the ductal genes, there are qPCR arrays you can run, right? There are arrays, you can actually design your own array today. So there were days that we will not be able to. Today you can design what are the genes you want to. For that, to select those genes, you have to do research. You have to collect a lot of information and then put it together, right? And then we analyze the tumor latency. What does that mean? The tumor latency analysis is that we put a lot of 10, 15 mice together and we do the control alcohol, chronic pancreatitis and alcoholic chronic pancreatitis mice. And alcoholic chronic pancreatitis mice, they die faster. They make tumor faster when compared to just alcohol. Just if you do the alcohol, maybe they may develop tumor or may not develop tumor or tumor-like ductal cells, but they will not become cancer cells. They go back, right? And the chronic inflammation, they go back. The alcoholic chronic pancreatitis is actually pancreatic one is actually one. With the KRAS I'm talking about, with the KRAS it will go further. Without KRAS I'm talking about, they go back. With the KRAS they go forward. With the KRAS I'm talking about tumor latency. That means that ACP developed the the tumor faster, right? So now all done. Now what is important for us as a cell biologist, for me, understanding the signaling. We are curious. As a cellular biologist, we want to know the signaling. Joshi also wants to know the signaling. He works on the F1 alpha. And someone else, he was actually curious on F1 alpha. I was asking him, why F1 alpha? But we have different ways of thinking, right? Our ways are different and his ways are different. Like that, every researcher think differently. So you think differently. You may think that, oh, EGFR I will study. Someone will say, I want to study maybe AKT. Okay, yeah, go ahead and study. And tell me why. The reason you have to give me why. Important, right? Okay, there are tons of people who have done already AKT. Why you are doing also? You have to tell me the story though. We have done AKT, but we know the reason why AKT, right? It's important. So then we did the kinase array, means all the kinases, we did the array, and we selected the top kinases that changed. And one of the kinase that we selected is the CREB, because I already was studying on the CREB and also that popped up here. And we saw that with the alcohol, the CREB was going up and it was going down again. Means that it is activated when it is damaged and it's going back when it is recovered, right? And we did that study, different models, different ways. And then in KC mice, in the KRAS mutant mice, we saw the expression of CREB beautifully. Look at that. The CREB is expressing, that is the CREB is in the green, is here, and expressing on the ductal cells nicely. Wherever the ducts are there, the CREB is there. So it's like you see in your own eye that it is working. It's expressing. Means that you know that it is working. So that is very important. Important is that picture. Seeing yourself that this is working is a key thing, key factor. So picture perfect, right? You say, oh, this is a picture perfect. That's how it should be. The CREB is activated. You see here, there is no CREB here. When you have a hit with alcohol, we see the CREB. Now we got confirmation. And now we took all the pancreas tissues. These are all tissue analysis. And we took like three mice of each study just to run the protein of the phosphorylated CREB. We saw, with a 3-day, 21-day, or 42-day, means that CREB is not going back. What does that mean? Means that the KRAS is activated. The CREB is a cyclic AMP responsive binding factor, is one of the transcription regulator. If you study molecular biology, the CREB and all these things will come in a, CREB is one of the standard master regulator. So we can talk about CREB later, but important is not CREB. Important is that you think like, there is one target is activated. Okay, think like that. It can be something else in a different cancer, right? Maybe somewhere in AKT, somewhere in the PI3 kinase, somewhere in STAT3, somewhere in some other model, maybe in other model, maybe something else, right? So this way. Here, we were even more curious. Can we do some mice model? Can we add something like in a color through the mice? You know what I'm saying? So that we will see exactly what is happening to those cells. So we added this, green color to these mice. Means that another mice we added attached to this, and with a green color. And this, wherever this Cree, means that wherever the pancreas cells are there, ACNR cells, you see the green there. Okay? These are all this natural. We are not put a color or anything. It is a natural mice model where wherever the ACNR cells are there are green color. Okay? The same way today you can make tomato color, you can make different colors of your different. So it is to study, it is to understand the biology of it. It's a technology developed. So we have to use it though. You have to use it and study. So we use that mice, and if you see here with the YFP, that is YF means a green color, and the CK19 is the ductal cells, and the phospho-CREB is our red color. We added these two colors. This is natural color, and wherever the YFP is there is a CREB is there. What does that mean? Means YFP is changing to blue. means that green is changing to blue. You see the blue colors here, that means that the green is changing. The green is going away. That means this mice cannot hold the green anymore because it's damaged. The ACNR is gone, normal cells are gone. Now they're all ductal cells, right? That's why you see those cells changing. So that was curious. We were curious and that happened. And just to show the model that the Krebs is activated and keep going, means that we were now interested in Krebs, okay, even more interested in understanding the Krebs and the biology of the Krebs, where it is going, how it is happening, and where is this Krebs binding, why only Krebs, why not something else, that means that what else is Krebs doing, things like that. So this is maybe a one model. Remember, for you, it's just concept ideas, okay? It's maybe a Krebs for me, maybe something else for you. But you have to think, it's just a concept idea. When you get that molecule and the model running, right, you have to think what else you can do. And then we created the Krebs knockout mice. That's what we do as a biologist. What we do, okay, now Krebs is activated, take that off. See what happens. Delete the Krebs. And then if it is Krebs, that means that if it is deleted, what will happen? It should not happen, right? Cancer should not come if it is Krebs mediated, right? Then what we'll do, if that is true, we develop the drug to the Krebs and then we treat this patient. This is how we do to the treatment. This is how you develop the model, you develop the concept, you develop the idea, and you model that idea in the research, and then you model the mice and study, understand, and then you go back and try to develop the genetic mouse model and delete that gene and study, and then if that is true, because genetic model when you study, it's true, that gene you deleted it, right? It's working, and now you target, you develop the drug, and next comes is okay, Krebs has a drug or no? We don't know. We'll come to that. We'll talk more on that. Okay. And then what we did when we deleted the Krebs here, we studied and making sure that the ACNR clusters, and when the Krebs is deleted, all the ducts were not forming. The ACNR cells are ACNR cells. There was no ducts. That means that Krebs is working. So when you delete Krebs, with the KRAS mutation, there are no ducts. Means that it is ACNR to ductal reprogramming, means that it is reversing the process by deleting the Krebs. Okay, and also just to make sure, when we deleted the Krebs and whether we have more ACNR cells, okay, we lost the Krebs duct cells, and there are more ACNR cells. What does that mean? We are also trying to understand in the transcriptionally gene level that okay, we still have these normal cells in the KRAS mutant mice model. In the KRAS mutant mice model, what happened? ACNR cells went into duct cells, right? Now you deleted Krebs, and now that there are no duct cells, there are still ACNR cells, even though there is a KRAS, right? The Krebs was mediated in this process, means that Krebs is really working. That's why Krebs was popped up when we did the kinase array assay. Remember, in the research, it is not just one-time experiment. Only you're seeing years of experience in one slide, Krebs is activated. But to get the data, you have to struggle. It is easy, one slide, one data, but it is not that easy, right? When you do multiple mice, there is a multiple way of data you get. So you as a scientist finalize yourself that what data you're going to take that and move forward. Based on many factors, that is research. Again, it's not something that, okay, oh yeah, I took it and moved forward and it worked out. Probably in the movie, not in research, right? So it may not work that way, but you have to, as a scientist, sometimes you have to analyze yourself, think yourself, develop some thought process, parallel thinking, okay? So if you take there were other kinases I did not take. You can ask me.
Why you didn't take the other one? Because I want to take something new. I want to study something new. Maybe there is AKT also doing the same thing. There is something Stat 3 also maybe doing the same thing. I just don't know. But Stat 3 is well known. AKT is well known. Krebs is not at that time. Now it is well known because we published it. But what I'm saying is that maybe Stat 3 is doing. You may ask me, okay, that means the drug is working? How? Stat 3 was also activated. AKT is also activated. Maybe they are still activated. Yeah, they may be activated. But this is also working. That also may work. Okay? Then, for example, if you take a disease, there are multiple drugs. Okay, if you take a fever, there are multiple drugs, multiple compounds work on the fever, but multiple targets. Remember, but it actually takes care of the fever. The same way, here, it takes care of the models and the study. It's the same thing, same concept, same design. You can ask me many questions, but as a scientist, you have to have a analysis thinking. Analyze it, put a common factor, and design your own science and ideas and science, things like that. So I just don't know how much time I have. Yeah, we can continue afterwards. Okay. So let me stop here. I know that you're all hungry. We can continue afterwards. But what I wanted to show you next is we are deleting the Krebs. Okay, say in my part is a Krebs, maybe for you something else also. Think logically in your research or the way, or maybe if you wanted to do something research in your own model, think logically if something Krebs kind of a thing comes to in your lab, some other molecule, how you want to study, why you want to study, the same concept, same design, curiosity, develop interest, and design your model. That's all I'm trying to tell you. So maybe after lunch we continue this, and I'll tell you more story about it. Remember, I'm taking a pancreas as an example. I'm giving you a hint how you want to study because it's easy. For me also easy, and for you also to understand with the data, with the our own realistic ideas, how we developed, probably will help you. So all our, most of our talks every day, same concept, same design. Thank you.
So before lunch, I think we stopped here, saying that this data, clearly suggests that Krebs deletion limits the ACNR cells to become a ADM, reprogramming. So that means that when you delete Krebs, okay, so it actually makes it normal, even though you have a KRAS mutation, right? So means that Krebs is definitely a kind of mediator in this study. So next what we did was we did the histological evaluation of the KC, that means KRAS mutation, plus KCC, that means KRAS with the Krebs deletion mice with the ACP induction. So that means that this is the control, that the KCC means that Krebs deleted here. And when you have a Krebs deletion, the tumors, when you have a KC with ACP, remember, when you have alcohol with the KRAS, that always made tumor, right? Now I deleted in the same one with the ACP and the KRAS, we deleted the Krebs, and now the tumors is gone, almost gone, but it's there. Some inflammation is there, some mediator. Remember always, I just stopped saying that there are STAT3 activation, there is other signaling activated. Just even though we deleted Krebs, there are other signaling. STAT3 is another inflammatory mediated transcription factor. Means that when you have inflammation, STAT3 get activated. AKT is also the same way. So inflammatory mediated activation. And there is a mTOR signaling that is also kind of mediated to the inflammation mediated. So these are all inflammatory mediated markers, only what we got when we did this kinase screening. So that's why tumors are not completely going to go away. So when you study, when you don't see tumors are all gone, it's okay. You're not making tumor gone. It will not be easy to make tumor gone. If someone come and says that tumor is completely gone in my study, do you believe? I don't believe completely, because there is no single one signaling pathway. It is like multiple signaling pathway that activates this one, different. There is nothing called like our body system interconnected with everything. You take each different cell type, they are all connected. There are signaling pathways. All see in one cell, we understood what 0.009%. That's all. What you know in cell is nothing compared to what we have in cell. We understood cell, I think, very small amount. So there are a lot of things still exist, but we were not able to. People move on to something else, but if they forget the simple cell, what's going on, they get excited with the T cell, excited with other cells. Yes, they're all important because they're all giving us the result. It's important. But that doesn't mean that we understood the cells. Okay? So it means that we still have a lot to understand just a cell itself. There are a lot of investigators, you might not see them, they're working very hard understanding these things. When you saw mRNA vaccination, the whole story of it, people read about it, the person did not get the grant and thrown away from the university, and because there was no grant, no money, the grant was not funded. That was the one you got the vaccination and saved many lives, right? So it's about the work. It's about that person. Probably many people might have told her that your work is not going anywhere, and I don't think it's pioneering work, and maybe I don't know. But it's not about that. It's about you, what you believe. You know what I'm saying? What you believe is always right. Okay, you believe in it with the experience, and you put all your mind and thoughts and work hard. There is always something will come out. So I think that's what we also kind of learned when we are doing this. We have to understand. So for example, my students will come and say, sir, tumor is okay, but it's not completely gone. This person, my postdoc, I had to train him and tell him, okay, this is the story. Okay, it will not go away. These are the reason. Okay, it will always be there, but the important is that deleting this has any significant effect. That's all. Is that mathematically it is affecting? Statistically it is really doable or not is the key thing, right? So that's what that's the story of it. Doesn't matter how you do, what you do, end of the day, so whether you're seeing it significantly or not, comparatively, okay? So we saw it significantly, then we moved on. We deleted, it's all gone, look at this. And then we add the ACP, and it is a 21-day recovery, and we saw KC, and it is there, and KCC, it's gone. Means that tumors we analyzed here, tumors were not there. That the cancer here, like for example, there was no cancer cells we saw in this model. Means that Krebs is doing something, which is actually important in this study. That's how we calculate and decided, okay? And then further we analyze the reprogramming in this model, like exactly how we did before with the PTF1A cream mice model. And here, in this control, we have a Krebs deletion. And you see here in this area that the KC mice, and you see some ducts here, but we don't see the ducts. But when you have a KC with ACP, you see a lot of ducts. You see the red one here. That is a CK19 marker. And there is amylase here. Amylase is a kind of marker on the ACNR cells. Like the same way, different cancer cells have a different marker. Okay, in this pancreas, amylase, remember beta cells and your pancreas, amylase, you studied all these things in your biology. Amylase, beta cells, yeah, alpha cells and all those things. So amylase is there, that means that ACNR cells are active. ACNR cells are very important for pancreas, and we will talk about it if you are interested. But how important, if you are interested in pancreas, we can talk in detail. And what I wanted to show you here is the KC model. The KC with alcohol, you see the ducts here, and you see the nucleus staining here. And now you delete the Krebs here in this model, and in the same ACP induction, and you don't see the ducts. You see a recovery. That means that you're coming back with some more ACNR cells, and we don't see ducts a lot. Okay, so that actually analysis and showing that we are not seeing the ducts much. And now taking that data, move forward, and we just do the realistic mice model where we did the amylase. Remember amylase staining in the back? So that amylase we replaced with the mice model having the GFP, that is a green fluorescence, right? Same like before I showed you. And what is important here is this is tumor with the ACP KC model. Y means YFP signal. And now you have a tumor and you have all the ducts. And now you see with the Krebs deletion, and you see only ACNR cells. Hardly you see any ducts. That's actually exciting science, right? The simple science, but it's exciting for us to knowing that the model is working. So that we analyze with the qPCR, go back and do all the genes which is known, and then we see that there are a lot of ACNR cells when you do this, okay, when we delete the Krebs, okay. And then we went back and analyzed the tumor latency, and now Krebs deletion, you see much better than compared to the KC mice with ACP, and now tumors are delayed, but they're coming, but delayed completely. But if you keep these mice longer, probably there are other activation. What does that mean? But you delete the Krebs completely, these tumor cells, if there are tumor cells, they always fight back and try to come back. Say for example, your tumors are, doctors say your tumors are recovered. Means that there was no tumor, and they did the surgery, and after a while the tumors are recovering. That's exactly what happens, because these signaling pathways are activated again, because they're all interconnected. There is nothing called like completely gone. Okay? Oh, we say that this patient is survived forever. There is no survivor forever, but survived longer than. But probably the body is fighting back such a way, the immunity power is more stronger, because this person don't have any other problem or the body is metabolically active, probably this patient is recovering. That doesn't mean that all the patients can get recover. The other patient, if you see, but probably not, right? It's all about, it's not, then we say doctor is a miracle, this doctor is miracle. Yes, our body is also miracle. So it's not just a doctor. Our body is also miracle. Some body is also miracle. The metabolism, body structure is entirely different. So it's all matters. Doctor also knows that metabolically your body may be stronger based on many analyses that they have done, studies. But the overall in this study, that I'm going to go to the next one. I'm going to show you more. I think Satish was interested to know P53, and I'm going to show you that. But in this study, Krebs, we understood that Krebs is one of the mediator. We can delete Krebs, and Krebs is definitely doing something in the progression model. So that is this whole story. And then now we understood that Krebs activation is a key factor in the pancreatic cancer progression and aggressiveness. So okay, then I'm interested in Krebs. If this is definitely doing something, I think I'm going to go and study more on Krebs and see what's going on. What happens with the P53? What happens with the something else? Okay, just sorry. Hello? Yeah, I think that I did something there. So we got interested in this Krebs. Now I'm going to show some data highlighting on the other two hallmarks of the studies from the lab. That I showed you one hallmark, that is the risk factor. So I showed you the risk factor, one of the alcohol and the KRAS and genetic model. And there are two other I showed you. One is stromal, another one is on immune. Okay, now we're going to go over to the another one, something called stromal or some other resistant pathway, and how that's controlled. Remember, I'm coming from the tumor cell type. I'm going out of the tumor cells and trying to tell you the environment around the tumor cells, how that's going to influence in your tumor progression. Also, understanding tumor intrinsic means inside the tumor, means the epithelial cell. Tumor extrinsic means outside the epithelial cell. What we can interact these two different cell types and study, and how do we study, modeling it and all those. So today, again I'm stressing, these are all the models already done. Now we're going to go back later and tell you basics of all these things one by one, so that you know the realistic data, and then we go one by one, how you do it, in your laboratory, and when you go back, and you have a plan to do something, right? Okay. In immunosuppression studies, we noted a significant increase in activated Krebs levels correlating with tumor burden. For example, if you say this is a KRAS one, and we added here KPC, means that KRAS plus P53 mutation. Okay, so we added another mutation to this without any inflammation, no inflammation. Just add another mutation to it. Forget about all the alcohol and all those. That's for the inflammation study. So we studied and we understood that Krebs is important. Now we are coming back to, okay, in my body there is no inflammation. All I have is a mutation and different mutations. So what happens now? So whether still the Krebs or something else. Okay, but remember, as a researcher, I got into Krebs. Now I'm more interested in Krebs, understanding it. You can do many other signaling pathways. Important is that the tools that you develop in the laboratory, you have to keep studying that tool, using that tool. We developed the mice model, knocked out the mice, in a mice model, we knockout studies we did. We invested a lot of money in the knockout studies, so that we want to continue studying that mice model, see what else we can do. One other thing you have to understand, there's a graduate student, the PhD students come to your lab, postdoc come to your lab. So what happens, they will ask you, okay, what to study? Okay, we have already a mice model developed in the laboratory. We took like 3-4 years to develop these mice. Why don't you take these mice and study with the other mutation or something else, or do this, do that. Let's see what happens. Throw something and we'll see what happens, right? So exactly, that's what we did. We added the P53 mutation. There was another postdoc was interested to study what happens to the Krebs because so the tool is available. It's easy for the postdoc to add another model and study. Remember, there is always something interesting comes out. So that's the beauty of the research, right? So you added the P53, and now you saw that phospho Krebs was increased in when you add another mutation, and you saw this nicely. This is the RNA scope study. We'll talk about this if someone is interested. How to do the RNA scope is also another technology, where he is seeing the Krebs, which is actually this color. The Krebs is actually on the ducts everywhere, beautifully stained. Okay, so you saw the Krebs is really more than what you saw in the inflammatory related, studies that we did, and now he's interested even more because the Krebs knocked out model. Remember, in your model, in your study, in your investigation, or in your laboratory, or if you want to study, if you develop one knockout model, or if you delete one gene, you can do a lot. You can do a lot and study. But important is that knocking out or investing on something that one gene or one thing, one model is also important because you spend a lot of time and money. So you make sure that what you're doing is important and right. So because otherwise you suffer later, right? You spend a lot of time figuring it out. That one gene is unique. The one gene you've studied and understood very well before you do anything. So we did that. So now he is actually taking this to the KPC Krebs knockout. Means that he has a P53. Now he saw a lot increase in the phospho-Krebs level. Means that Krebs is very high, even with the P53. Now he is more interested. Okay, I'm going to delete this, gene Krebs in the KRAS activated and P53 mutated mice model. Remember, I can say easily, oh, he did that, but there is a lot of genetic model crossing is going on, right? You have to do, it takes years to develop those mice and making sure that this mice is correct. And a lot of, in the background, technology is involved. It means that making sure the model that you develop is the right model is also very important. How do you do that? You have to validate those models each and every step, okay? Making sure that this model, I don't show all those models. People don't show all those, how we validate. It is your responsibility as a researcher, validating that what work you do and you're actually doing it right. Otherwise, you're actually, it's dangerous for later on for you. Okay, you get the money for the grant and then grant is gone because your model, what you validated, is not right. And probably you take that to the clinical trial and the patient die, and you're going to be targeted because you never know what went wrong. Because that's why validation is a key step. Making sure that that gene, when you delete, is really deleted, and making sure that when you activated something, it's activated. These are all the key steps that you learn on the go. So when we knocked out, when he knocked out Krebs here in this model, Krebs was gone, and now you see when Krebs is gone, is not there, you see the pancreas weight is gone. Like, look at that. It's very tiny pancreas. It's like completely, it worked even fantastically when compared to the other model that what we had. We just don't know. I'll tell you the story even more and more. We published in a Cancer Discovery, one of this, tiny little study, with my colleague, that, looking at that, how that exactly P53 is regulating the Krebs. You know what I'm saying? So we continued doing that in the laboratory. Now there are other papers coming, but the important is this, that I'm not talking about the biology of it. I'm actually showing you model how to develop, rather than a lot of research underneath how these are all regulated. You know what I'm saying? So when we deleted the Krebs, the tumors are all gone. means that there is a tumor, there is a little bit of tumor, but it's almost significantly gone. And the mice survival completely increased. You see, it's 137 to 223, means that mice survived longer. These mice, when you deleted with CREB, and remember, these two mutations in pancreas is very, very bad, okay? But with that mutation, the mice are surviving, especially when compared to the mice age, to the human age, it's entirely different things. We will talk about that too. So when the mice is 100 days, what is it compared to human days, right? Those kind of things. It's available you can Google it, but we can talk more on that. And when you saw the metastasis, you know, another thing that we're going to add later on in our talk and discussion, the metastasis. You know, metastasis means that the tumor cells go from one organ to another organ. Remember, we talk more on this in more detail, but in each cancer, metastatic cells goes different organ in a different cancer. Okay, it's not the same. Okay, for example, in pancreas, it go to liver, probably in other cancer somewhere else. Okay, this kind of, because of the blood vessels and how the blood flow through that organ and where it is going, where it is sitting through that, you know, it's all about that. It's all about the human physiology. Another thing, that human physiology is also important. You may be a biochemist, you may be a biotechnologist, but understanding the physiology of the human body is also a key factor. That's why we need to have the colleagues and different friends and you know, scientific friends, so understand and study and discuss about all these things so that you can actually model it better, your mice model ideas and how you do this. So this metastasis, if you see 11 mice, 1 mice had metastasis, when compared to we had 13 mice, we had 7 mice metastasis. It means that you know, you can ask me, okay, why 1 mice? I just don't know. Okay, we are just doing the statistics of it. Okay, 1 mice, I just don't know, because there may be we check every mice, making sure that genotype, you know, it can happen, because we don't know. It's just that's the reason that we added more mice, making sure. So you can say, okay, I remember one thing, when it comes to patient, the same paracetamol you take, one person, it's one paracetamol is enough. Another person, he needs more. He needs 2 paracetamol to sleep, you know, making the pain go away. Our body is also depends on many factors, metabolism, a lot of other factors. You know, it's not the same, okay? So drug is also the same way. Doctor also don't know. He's just give the approximately drug dosage, but your body might not, you know, some people take the, you know, night medicine, they can sleep. If some person take night medicine, cannot sleep. The coffee also same way. One person takes coffee and he cannot sleep. But so another person take coffee and sleep. Best sleep, probably. So it's the body plays a big role, and the whole system plays a big role here. So when I say metastasis, means that here we are showing one of the metastases. I think this is a liver metastasis. I think you can see that there are some liver metastasis model. I think this one, when we have the overexpression. This is not a CREB deletion, okay? This is CREB overexpression. We expressed CREB in those model, and he's actually showing that when you have a overexpression of CREB, you see the metastasis in the liver. That's what I think he's showing. This is another way of doing it. So when you show knocking out, you have to show the other way, overexpress, right? That's how you study in a scientific. Okay, if you sometime what happens in previously, we were not able to overexpress every gene. We have to look for the plasmid. Some people in Germany, then you ask for plasmid, they'll send. Maybe they will not send, and they'll wait and years, but they will not send. You keep on requesting. But what happens? The other way is that if you know how you can activate CREB, you can actually activate through signaling. If you can understand the signaling, you can activate through receptor-mediated activation of the CREB and activate that and see whether metastasis happens or not. We'll talk about those kind of models also later on. Okay, and that is kind of this data completely suggests that CREB is role in the initiation, progression, metastasis, and all those things. So now you understood this tumor intrinsic, right? Now I'm going to come out as a tumor immune cell dynamics in cancer progression. We conducted initially TCGA, you all know, it's all public database. You can go to TCGA database, you can actually download any of the patient data, okay? You can download any of the patient data, I know it doesn't matter which cancer. Remember, I'm going to talk about the tools tomorrow, what type of tools available in the world. It's important when you do this research, it's just not your lab and your work. It's about what tools are available outside so that you can actually use those tools. You can use those tools. And it's for the public data, publicly available data sets. Okay, there are many universities have a tool too. You should know which university website. You should go to some of the top universities. Some of them, sometime small universities, some of the investigator right there, probably doing something unique. Probably you have to search those histologically. There are some Oncomine, one of the website also. There is kind of like that. If you go and become a register there, and you can study, that itself is a huge data set for you. You don't have to do anything. I was telling you, someone you said, he told me about the cell culture, right? You don't have to do the cell culture if you don't have a cell culture. And believe me, there are a lot of tools available if you want to study science, if you want to study biology. It is not a cell culture, it is not a mice model only. If you are interested in understanding, you can learn something else which you actually sit at home and actually study. You don't have to be in the laboratory. What I'm saying is that if you don't have the facility, you're still interested, you can actually do tons of study, tons of ideas you can develop and model it and study from home. You think that IT people can work from home? No, we can also work from home if you don't have the facility. But it is a smart way you can actually think how to work from home, but still you're a scientist, right? So there are tools available, we'll discuss more. Further, we correlated this analysis with a lot of myeloid cells, macrophages. Okay, if the Krebs is really activated, if the Krebs is activated, whether myeloid cells are getting activated, macrophage cells activated, or T cells, we want to know whether the Krebs has any role in any of these cell types. Okay, that is the idea of the whole thing, right? We saw that in the pancreas, the macrophages are very important because they're very high number of macrophages. People ask, okay, why did you study, if I say pick something here, if I study, they say, why did you study macrophages is high in pancreas? You should take the macrophages. Now, how this person actually, what if you miss something here? You study macrophages. Okay, you know what I'm saying? So you never know. It depends on your research has to take you. Not that, okay, someone says, or another literature says that, oh, if you have increased macrophages, you should study macrophages. Where is written? There is nowhere written, right? So it's about your work has to take you. There are a lot of research you have to do in the background to understand that what this cell type, what this signal, what this different cell types are doing to the molecule that you are studying. So we took the macrophages just to see whether the macrophages are important, just to learn from it. And this co-regulation on the macrophages to Krebs, we saw the co-regulation. This was interesting to us. So we analyzed the human and the mouse pancreatic cancer cell specimens. Here are the human specimens. These are all the mouse specimens in the progression of the cancer. What he did was the F480 is the macrophage marker. F480 is also compared with the TAMS, that is in a human is a CD68 marker, is a TAM marker, and in the mouse it's a F480, and then compared with that phospho-Krebs expression, and he saw my postdoc saw that increase in the phospho-Krebs and with the macrophages, they correlated very well. Means that when phospho-Krebs is high, then the macrophage is also high. So then we did something on nanostring. I was telling you about the nanostring study. So is a spatial studies. So there are a lot of technology. These are all the tissues here. Okay, we stain with different markers like this. Like for example, we take green as a pan CK, that is a CK, the ductal cell, F480 for the red, and then pan CK plus 480 for both. We stain that, and then wherever that we select that area, okay, whether the immune cells or the tumor cells, we select that area. Wherever these markers are stained, we only see those markers and that area genes, okay, genes around that area. So like that, we select that area and tell the transcriptomic analysis that only in that area I want to see the gene list. Okay, so I want to know what happens only in that area, because I'm only interested where Krebs is binding in the macrophage, or however it is, whatever it is happening to macrophages, whether Krebs is doing it or something else doing before the Krebs. Krebs is intrinsic to the cell, but Krebs may be intrinsic, means that inside the cell nucleus Krebs is regulated, but outside Krebs is going to other cell types, or some other mediators are there, Krebs is regulating, and that is going and binding to other macrophages and other, so kind of like that. So we studied to understand that, and then what happened? So now you know the macrophages. Oh, you know these are the macrophages. Now you take the macrophages, isolate the macrophages. That's what we did with the Krebs knockout and Krebs wild type, and you do the like for example tumor cells, right? Same way we took the macrophages, because we were interested. Now we know the macrophages. Macrophages, something is happening. So we KPC cells we took. KPC means that KRAS P53 KPC cells. We made the mice KPC, right? And we made the mice KPC with the Krebs knockout mice, right? In those mice we took the macrophages, isolated the macrophages from those mice, and those then we analyzed the kinases in those mice in the macrophages. Means that to understand in the macrophages what is happening, like how we did in the tumor cells. We did the kinase array in the tumor cells, pancreas cells, right? Same way we did in the macrophages. Now you can ask me why, what, how, what for. Remember, the science is changing. Means that 10 years ago we used to talk about only the cancer cell, transcription inside the cell and everything. Now it is not like that. Did you do the transcription analysis on the macrophages? Did you do T cell transcriptome? Did you do B cell transcriptome? Did you take the calf cells and did the transcription studies? Because people are interested to know what these cells, different cells are doing, and how this transcription changing in different cell types. The same way we took the macrophages and we did the kinase array like how we do in the tumor cells, and now we want to see, because whether this signaling is there or not, what signaling they have, so that we can understand whether the Krebs is interacting with some of this, any of this signaling there in the macrophages. Because I'm going to come to you and explain to you that tumor microenvironment. This is exactly what I'm trying to tell you. So I'm trying to tell you the story of the tumor microenvironment right now in this study, so that we can discuss more in detail of the tumor microenvironment. Why we want to study the tumor microenvironment. It's just a simple example. Then we got some of these kinases. Now what they are doing, targeting these kinases in the macrophages and trying to understand when you have a Krebs inhibitor and they want to see what happens to these kinases. Like that, you can actually study different kinases in different cell types too. And then what he did, he collected single suspension from these tumor cells, say for example, the Krebs wild type and the Krebs knockout in the KPC. This is not just the KRAS. This is with the KRAS and P53. And then one of my postdoc, he started studying with the KPC, in the KPC model with delete Krebs, what happens. And then he analyzed the macrophage clusters in these tumors, and then he looked into STAT3, IL-6 signaling, and I can explain to you why you have to study specifically that, because of the expression, it is STAT3 is deleted, things like that. Okay, we can discuss more. I'm going to go here a little bit of more of immunology, but I'll tell you why. Because when we understood the cells and we are coming out and understanding the other cells like immune cells, so that I can connect both of them, This is how it is happening. Okay, that is why we use the Krebs inhibitor. So these are all the questions. Okay, I'm going to interact, study both. So here, what we did was we wanted to see what happens to these immune cells in all these mice models, in a Krebs knockout or the Krebs wild type mice model. By silencing the Krebs, overall, I'm going to explain to you that it disrupts the human suppressive microenvironment. So it affects the macrophage polarization and also increases the T cell infiltration and reduces the tumor growth and enhances the survival of this genetic model. And also we have seen in the orthotopic model, this confirms the Krebs role in the whole tumor immune microenvironment. So overall, I'm not showing you all the details, but what I'm trying to tell you is that when you study one cancer cell, you have to start studying the other, different cell types too. Okay, because you want to enhance your work in a high impact. Okay, I think Vice Chancellor was telling, you have to increase the impact of your work. If you want to increase the impact of your paper, you have to start thinking differently. Just not cells, just not one cell. These are different cells, interaction, many ways, different ways. Two, now I'm going to come back to the link between them. Okay, to understand how cell intrinsic Krebs, regulates the tumor immune microenvironment. You saw it now with the T cells and all those. Okay, we conducted a differential gene expression analysis, which showed that significant downregulation of LIF. That means that when you knock out Krebs, the LIF is one of the leukemia inhibitory factor, which actually went down. You can ask me, okay, why LIF? There are other factors, why you didn't select? Okay, but at that time, one of the LIF is one of the mediator. Remember I showed you STAT3 before? Remember, there is a paper came out in Nature saying that LIF and STAT3 interact each other and there is a signaling pathway. Since we saw the STAT3 signaling over there, so in the macrophages, I thought LIF may be the one of the mediator I think we should study in the Krebs related model. That's why we selected. This is important again. What is important? There may be other factors also involved, but select something which actually someone actually published, who actually shows the impact of some of the molecule. Actually, you're also seeing the same thing, but differently. Your main goal was Krebs, but maybe your gene may be IKT, your gene may be EGFR, but in a different tumor model. But end of the day, you have to show the reviewers and you have to show to the world that you are also seeing something similar to the other scientists are also seeing it. It's a key factor. Otherwise, nobody will believe. Otherwise, it will become like a mRNA vaccination lady, which actually never be able to get a grant, never be able to publish a paper. The thing is this, that you want to publish a paper, you have to relate something somewhere. But if you want to, that doesn't mean that you should not keep studying the way that you're thinking. Our lab just not working on just what LIF and all. No, our investigation I'm not showing you. So we always will be ahead of what we are actually showing you. So we are interacting and studying much more than what you're seeing. But what I'm showing you, what we are publishing or what we are publishing in the gym, that means that outdated work we publish and the real one is already running in the laboratory, right, which you may not see it. So the already done work, and we are done with it. We are changing the science in our lab, then we publish it. Okay, then you see it. But that doesn't mean that is new. Okay, the new thing is always running in the laboratory. Okay, so this reduction in the LIF, when you have a Krebs knockout, you see the LIF release is reduced, LIF expression is reduced. We did the ELISA, qPCR, and also LIF level in different clusters. We analyzed it. We also did the EpCAM positive tumor cells. That means that epithelial cells we took and also analyzed the LIF source. Many ways we tried to establish that LIF is important. And also we did the ChIP-seq analysis where we pulled down the Krebs and we see whether the leaf is binding to the Krebs. We saw leaf is also one of the factors that actually binds to the Krebs. This is very important. So when you do the transcriptional study and when you are trying to understand how this is regulated, you have to understand there are a lot of technologies available. You can do the chip-seq analysis, show that it is binding to that, and that is exactly what we saw. Leaf is binding to the Krebs. That is the story. And then we did the correlation analysis showing significant association between Krebs and leaf. Yeah, and also when you have a Krebs and leaf together, it's a worse survival when compared to just the Krebs or the leaf. That means that Krebs-leaf association is very strong. This is not just in the pancreatic cancer. We are actually showing that association with the esophageal cancer, gastric cancer, colon cancer also. Remember, all this data we selected from the TCGA is publicly available. Anybody can use it. Okay, anybody can analyze it. Okay, but important in this in this study is unique. What it is means that Krebs and leaf, which is unique because no one has showed. That is unique. That is what I think you need to find. Okay, and then what we further went ahead and we wanted to see whether Krebs regulates leaf, how this regulates, how in the transcriptionally we also showed and we validated this in a different experiment here. And then what we did was the next one was LIFR. When we know that LIF is activating the macrophages, so that means that LIF is released from the Krebs. When we deleted Krebs, LIF is down. When we activated Krebs, LIF is up. Means that the LIF is a releasing factor. It releases and went on to the macrophages and binds on the macrophages through LIFR. Means the LIFR is a receptor on the macrophages and it binds there, activates some signaling. Okay, activates some signaling in the macrophages. That's why we did the kinase array to see what is activated in the macrophages. And now we are coming back and connecting that the whole story. Okay, here we inhibited now. Okay, we come to understand that Krebs leaf is important. Now macrophages are important. Now we know the whole story. Okay, somewhere under T cells are activated, immune suppression and all those things. What is next? People ask, okay, did you develop a drug? Do you have a drug? Can you target with the drug? Why? Because you want to take to patient, you have to have a drug. You cannot delete gene in the patient, right? You have to take a drug. So next, what we did was we did the drug study that is called one of the only drug that available in the market is a 66615. Is that drug we used it in the model, and we saw that when you use the drug, it activated the CD8 cells and PD1 positive T CD8 cells. That means that we can use the immunotherapy in the study. So that's why we did that study, and then our study dragged us to investigate further on immunosuppression because it's activated. When you use the Krebs inhibitor, it activated immune cells. That's why we wanted to study the immune suppression and focused on overcoming that tumor microenvironment, the immune suppression effects. Current strategies include modulating the immune suppressive cells and also when your immune cells are like activated T cells, that means that you start thinking about using the immunotherapy, right? That's how. So what we did was our next goal is to disturb the immunosuppressive cytokine milieu. So making the immunotherapy is a promising direction. So sorry. So in the advancement of immuno-oncology have led us to human mouse chimeric models. We used humanized mouse model with human myeloid and T cells to increase our studies human relevance. Remember, in the mice don't have immune cells. Okay, that's why if you want to study immunotherapy, you have to have immune cells in the mice. So you have to develop that type of mice to study. Okay, that's why we developed the mice with the immune cells, and we added this PDXs, patient-derived xenografts. We did that patient-derived xenograph. Means that we took the patient tissue, pancreas tissues, and we put that in the mice, and these mice are humanized mice, means that these mice comes with T cells activated in these mice, myeloid cells are activated in these mice, so you use them, do the immunotherapy. That is also very important. So that is uniqueness of your models. That's how you develop the novelty in your model, means that translational novelty, means that if you want to translate your study, you have to use the right model, right mouse model when you are conducting your study. Or when you are conducting your study in the in vitro also, or in the tumor, if you want to show that mimicking the tumor microenvironment, you have to use the organoids. We will talk about that, and we will talk more on whatever microenvironment you want to create when you are studying in vitro, right? I'm talking about in vivo. Here, my mice has to have the immune cells. That's why we developed the immunized mice model. Remember, it's very expensive. One mice is $3,000. Okay, I just wanted to let you know. So that's a lot of money, right? So that means that you cannot have one mice, right? You have to have multiple mice just for one study, just a vehicle study, and also Krebs inhibitor study, and also Krebs inhibitor with the immunotherapy, just immunotherapy alone, things like that. It's a lot of money investment to study those kind of study. Sometimes it might fail. You might spend a lot of money, but the experiment might fail too, because someone trying to sell you the product, it is just not in the market. Even in the science also, someone is trying to sell a product, but the product may not be the one that probably you're thinking, maybe not be correct, because they are not validated in every environment. Our environment in University of Miami is different than maybe in the Vanderbilt University or in the Boston, some other university. Environment is different. Even though we say changes, things have happened in those mice too. Okay. So we use this, we implanted pancreatic cell cancer or PDXs, patient-derived xenografts, and then which expressed high ductal cells. We verified, making sure it has a Krebs. Then only we injected to these skid mice, means that it comes with the immune. Then combining the Krebs inhibitor with the anti-PD-1 antibody, which reduce the PD-1 positive mature, CD3, CD8 T cells. We are exploring this, whether Krebs inhibitor enhances the pancreatic tumor response immunotherapy in this kind of model. So it's kind of what I'm trying to tell you is that, if you want to translate your study, you have to use the right model to show that your study is translatable. People believe in your work, then only the medical oncologist will come and take your study to treat the patient. He has to develop the protocol to treat. So to treat, then there is a procedure involved. That's why we have to conduct this type of study. Then we also did the orthotopic, means that you take these cells, orthotopically inject in the pancreas, and then the tumor develop. And then it means that you open exactly like how you do the surgery. We open and put the cells in the pancreas and then close it and do the surgery. And then this will grow, and then we do the immunotherapy with the Krebs inhibitor, and then we saw very good survival, means that these mice survived much better than other mice, means that immunotherapy is working in this mice model. So you have to validate those kind of studies. And then we did the ultrasound imaging, making sure that when we are doing the survival study, we cannot sack these mice, all right? You cannot kill these mice. We have to keep going, like how exactly the patient go to the imaging center and get it done, and then you say the tumor is ready user or whatever. It's the same like we did in the mice. We saw that tumor was very small when compared to vehicle, that is with the Krebs inhibitor with the immunotherapy. So that's how we knew these mice going to survive longer. So we keep going and treating these mice for a longer time. So this is something that I'm showing some translational relation to our study, specifically using the chemotherapy. Means that when you do this type of study, people ask you the one thing, or even the medical oncologists who actually want to treat the patient, they'll ask you, there is a standard chemotherapy already available. Like you all know that when the patient go to clinic with the cancer, they'll do the chemotherapy or the surgery. There's a standard chemotherapy available in the market, and you have to conduct those kind of studies with the standard chemotherapy, because that's how they're going to treat in the clinic, right? They're not going to treat your drug you developed, no. They're not going to treat your model you developed, no. They first ask you whether in your model you did the standard chemotherapy, because that's how we treat the patient. So you had to do the standard chemotherapy. We did the standard chemotherapy with the gemcitabine and paclitaxel. That is a standard chemotherapy for pancreatic cancer patients. They survive up to 9 to 12 in a month. But before it was only gemcitabine we were using it. Now I have published many papers with gemcitabine. At that time, the standard chemotherapy was gemcitabine. And then the survival was only 5 to 6 months. That's all. Patient come and die within 5 months or 6 months. Now the patient survive for 12 months, almost 13 months. So that is a standard chemotherapy we did with the GIAN inhibitor, and tumors were really reduced. And we saw tumor reduction in the ultrasound. This is not great. Let me tell you, when compared to the GIAN inhibitor with the anti-PD-1, right? That was much better than this. But you have to the data they are not going to do in the clinic. They have to do with the chemotherapy. They are not going to do it. Okay? That's why you have to do the standard chemotherapy. You can ask me, then if this is worse, then why they are doing it? Because that is how the protocol developed. That's how they're going to treat. They're not going to change the protocol, right? Things like that. We can talk about that when it comes to a clinical development of your study. And if you are anybody interested in clinical development, and we can also even interact with you, and more, I can discuss with you. So now we know that molecular mechanism of this CREB-LIF in pancreatic cancer oncogenesis. What I was trying to tell you is this, okay? Probably you didn't see this picture before. This is the tumor cell I was always talking about. This is the macrophage I was talking about. This is the immune cells I was talking about, T cells, okay? I'm telling you the CREB was activated in the nuclear, CREB regulated the LIF, and we knew already how we studied all these things before. We understood the whole thing. This is all our research, okay? And now CREB regulated LIF. CREB also alone can do a lot of things. LIF also alone can do a lot of things, but together do a lot of things much more better, right? I showed you a lot of, when you have a correlation between these two, the worst survival you can see in the TCGA database, right? So this LIF, released LIF, it actually binds on the LIF receptor, okay, and activates STAT3. That's what you saw. We saw all the data. This is how we investigated, making sure this is exactly how this is working. That is how the immunotherapy, you add immunotherapy to this, it will block the whole thing, and the tumor progression was reduced. That's how you actually study. For example, you can ask me, okay, why can't you just do the CREB inhibitor? Why can't you just do the immunotherapy? Why can't it cannot. The research and understanding the biology is not going to work out like that. So you have to study different, what exactly is working. First of all, you have to tell me the story of how exactly your molecule is working, right? What is different compared to the other studies I've conducted? Okay, how impactful your study, how comparatively, how innovative your study. These kind of small things that you need to know when you start studying. So in this ongoing immunosuppression work, we learned that the CREB-LIF axis holds a therapeutic potential for decreasing pancreatic cancer burden, okay, modifying the immunosuppressive microenvironment. This is exactly what we did. I showed you this study before. I showed you now the immunotherapy. What I did not show you this here, desmoplasia stroma, right? So that is a little bit of story, okay? But it's interesting. Why it is interesting? Because in the pancreas, the same way I would have not showed you this if it is not pancreas, because other cancer may be a soft tumor, the lung tumor may be a soft tumor, maybe there is not much desmoplasia, right? In pancreas, completely desmoplasia. So completely tumor cells go away and comes with a lot of fibrosis, a lot of ECM factor, means that extracellular factors comes in, okay? The tumor's dense stroma impedes the drug delivery, the drug I was telling you about, when you have a drug in the tumor in pancreas that doesn't go in. So that's why it's important to study the stromal factor in the dense stroma in pancreatic cancer impedes the drug delivery and promotes the resistance. It means the drug resistance, making the tumor difficult to treat. This is a struggle they are going. It's going on in the pancreatic cancer field for a long time, like impeding the resistance, impeding the stroma. So we can actually treat much better if we can take care of this, right? And this is another study in the ECM, that is a desmoplasia area, where extracellular matrix in pancreatic cancer. So it is well known that ECM, that is an extracellular matrix, that is outside the tumor cells, where you see a lot of matrix around. You might have known, if anybody researchers are here, you all know MMPs, like matrix metaboloproteases. We used to study a lot, like 15-20 years ago, MMPs and all those things. These are all coming back because those are all important. Because they are all outside the membrane, and they all actually helps. They control. It is like our door. They control who should go in, who should not. So that's why it's important to study them and understand them before we treat the patient also, right? We are trying to understand the biology of interplay between the ECM and the CAFs. CAFs is also another factor. There is a fibrosis factor. So they're all novel. We can do some targeting ECM and stroma is also important. So there is a signaling pathway that is one of the pathways well known in the ECM field. That is a RO-ROCK pathway. Is a major signaling in the ECM remodeling, and our studies also highlight the importance of understanding this, signaling, area. I'm not going to go in detail and tell you all things because there's a lot to cover for you. But it's important to understand the tumor microenvironment around the tumor. I will tell you why. You'll be surprised why I have to study the tumor microenvironment. You have to study the tumor microenvironment. Then why, you can ask me, I'll tell you exactly why. You will tell me, oh yeah, it's important to study the tumor microenvironment later when you have after 4 or 5 days. Okay, we studied this RO-ROCK signaling and trying to understand that much more on signaling pathway. I was actually curious to show some preliminary data. I'll show you. So where we developed this ongoing research. So in the initial study in the TCGA data, remember I always go to TCGA data because it's freely available. You can analyze anything that you want to. Remember, your science has to be unique. Okay, and we studied the ECM signatures. We collected a lot of from the literature. We collected some of the ECM signature. You can do anything that you want to. For example, in your model, if you want to study, you collect some of the unique papers in your area, collect those genes, put that in the TCGA database, and try to mimic and see whether that helps you to develop your way that you're thinking, how you're thinking. Not only that, pathway. There are many other pathways that you can actually study. Not pathway. That is the TCGA type of database is available all over. In our initial study, the TCGA data showed that the ECM signature genes were overexpressed. That means that what we were thinking is also true, that ECM genes are important in the pancreatic cancer progression because they are the one actually culprit. They are the one making the tumor hard, and this is better to study, understand them, and see what's going on. Then we can actually target, delete, study, things like that, right? So we then conducted ATAC sequencing. So I don't want to go in detail of this. The only reason I will tell you, because the sequencing studies is interesting, because you take the whole genome and you sequence without the CREB, with the CREB and all those things, you'll understand the whole genome, what happened to the whole genome. Kind of that, what I'm trying to tell you is that when we deleted CREB, so we saw a lot of ECM factors went down. Okay, means that CREB may be doing something on the ECM genes. How, we will discuss more on detail. But that is research again. you have to go in depth. If that is doing, then how it is doing, right? And we saw ROC1, ROC2 were upregulated when you have a high CREB. This again TCGA database where we have a high CREB and also ROC1, ROC2 was high. Means that ROC1, ROC2 were regulated by probably a CREB, right? And here when you have a ROC1, ROC2, high, that is a worse survival. That is a patient, if you see, there is a worse survival. They correlate each other with the CREB. Both of them correlate with each other. And we saw in our model, KPC tumor, mice model, that is a KRAS P53 mice model, pancreas tumor. We took that, and we have ROC1, we have ROC2, we co-localized with the phosphocreb. Wherever the CREB is there, ROC2 is there. Wherever CREB is there, ROC1 is there. But when you deleted CREB, okay, when you deleted CREB, both are gone. I'll show you again. Here, CREB regulates lot of ECM factors, and CREB here, ROC1, CREB regulated ROC1, CREB regulated ROC2. That's basically showing in the ChIP-seq analysis, they are regulated each other. And when you knock out the CREB, okay, when you knock out CREB, CREB is gone, ROC2 is gone, ROC1 is gone. Okay, in the tumor cell, that means that they are regulating. We confirm, validate with many of the factors that what you're trying to understand scientifically, it is true. You have to confirm with a many other way, validate your study, many other ways, confirm that what you are trying to show is true. Okay. Then again, I'm going to tell you, we overexpress CREB here, right? We overexpress and see that ROC1, ROC2 is up, right? So I showed you the overexpressing CREB actually metastasizes, right, to the liver. And here, the overexpressing CREB is actually increasing the ROC1, ROC2 expression. So this is just a model showing. So overall, I think this project is interesting, is ongoing project, and there are a lot of other studies I wanted to show you, but it's going to be deeper. But probably I can show you later after 4th day, 5th day. Probably you'll understand even more in depth on this subject. So it's kind of we think that in this ongoing project, because all this project, we think that why I'm telling you this story, because you need to know how I'm linking one study to another study to another study, right? So all these three studies are linked to each other. Somehow they are coming along. But what happens is that any studies you do, you have to plan for long term, right? It is not that you study today and you wind up. No, you want to do something meaningful, you have to plan long term and understand this biology in different angle, different way. That's why I wanted to give you that curiosity of studying and understanding it, and also tell you that everything is possible because of all these people, right? Because they're all there, they learn each and every technology, they learn to help you to, for example, he's a master in gene deleting. He can actually overexpress. He can overexpress any gene. He can delete any gene. I can show you the model. That is his expertise. He actually does the ECM. He knows exactly what to do with the ECM technology, ECM studies. He knows that is his expertise. Okay. Nisha is an undergraduate. She's Anna is completely a genomic lady. She's a kind of a single cell sequencing, anything with the bioinformatics related studies and analyzing the single cell sequencing data, and it's her expertise. And she's a mouse model person. She basically do all the alcoholic mouse model, developing mouse model, and things like that. You combine. You actually do a lot of drug studies. Only drug studies. You only treat every day. You go every day, morning to evening, treat these mice and study. There's a lot of studies, right? So it's not one person cannot be done, right? Everyone has to integrate each other, but they're all unique in their own way. But you integrate each other, collaborate in our own, they are sometimes they work for other investigators. We collaborate with them and do it in our laboratory too. So it's you cannot just do it alone, okay? You have to have friends in every field so that, bioinformatics, immunology, and chemistry, developing the drug, and maybe neurochemistry and neurology, and things like that. So you can name it. Epigenetics is one of the important area. Vaccine is also important. Like this, they have a unique immunology, microbiology. Microbiology is also important, right? When you are studying the pancreas, you may have to have friends in gut, colon, lung. You never know, liver. These are all the things that you develop. This uniqueness, collaborate with them, and trying to acknowledgement to many people work on these are the grants. In the laboratory, postdoc, undergraduate students, collaboration with many investigators. These are some of the awards that one of my undergrad student got. It's a big award for her, and this is my scholar award in the ASR. ASR is a big event. It's a internationally known conference. So getting that scholar award is unique. So that's my students. So there's any questions and discussions and anything that you want to have, it's open for you. There's some references here. I can share later on all the references. It's in my CV also. They can actually distribute my CV to you, and you can have references there. They're all my laboratory publications and the one that I presented today, things like that. So, any questions? Yeah. Go. Yeah. Yeah, go ahead, you. No, it is there everywhere, but in pancreas is more. That's why the pancreas tumors are harder, right? No, not like pancreas. I told you they are of stroma, right? The biology is different. This cancer has a different biology. So when you are studying, tumor progression may be same in all the cancer, but when it comes to microenvironment, they are different. So that's why we need to study microenvironment too, just not the tumor intrinsic anymore. But important to understand the biology in the tumor intrinsic, because that is a master regulator, right? Tumor intrinsic, that's where that actually nucleus regulates a lot of other things. But important to know, but that's not enough. Yeah, yeah, that's ECM. Yeah. Always. But see, that is the uniqueness of this biology. But when you screen, for example, you take a fibroblast cells, right? That is from the pancreas fibroblast, and you take from the lung fibroblast, and you study the biology of it, signaling of it. Maybe there is uniqueness there. So that is how they act differently. They tighten differently. They attach to another organ, another molecule, or collagen, or 1 or 4 or whatever. They differently probably. So there's lot to study, learn, right? So anyone? Yeah, go ahead. So we have to have all both. So I didn't tell about male female. In our work, whenever we study drug study or the mice, any mice study, always, because I don't want to talk about confuse you, male, female, it happens. There is always a little bit of change, a little bit of different in the male and the female, and there is a lot of things. Male actually grow a little bit faster and things like that compared to female. There are many things we can talk. Drug study also, male, female, we always compare. We have to compare. Our grant actually clearly says that you have to compare. And our paper also, if you see our publications, we see the male and female differences. So sometimes, not always, right? Yeah. Always. Yeah, and the models are all, we don't talk about all the details, right? But when you see in the paper published, and if you see the methodology, you see at what age that we started the tumor induction, our studies, and alcohol also. You cannot, under 16 they cannot drink, under 18 you cannot drink. You have to compare the age group when you are giving to the mice also according to what age group people drink, right? Yeah. You mean to say when they are drinking? Like a, correct. You can do a lot of genetic study nowadays is available. After the Human Genome Project, very well. So we can analyze and all this. But it's again comes to the pancreas, right? You need to know the pancreas. Whether they have a tumor, any mutation in the pancreas. That is, I think, important, right? It's hard to know unless you take the tissue out. So you cannot take the tissue out unless you have a tumor. Normal tissues, they don't take it out. You cannot do the surgery. Normal patient, you cannot do surgery.
Can you take the genome of other parts and do the same polymorphism, similarly polymorphism?
Yeah, you can do that. For example,
Only pancreas, because so maybe all cells have the same set of genome. So can we analyze one cell of some genetic composition of a particular person? So we can find out which are all the genes which got mutated. Say, for example, KRAS mutation or P53 mutation. So need not be go and pin down only pancreas. Can we take other part of the cells and so have a genetic makeup?
definitely, you kind of guess it, but it may not be true, right? You can analyze it, you can guess it, maybe, may not, right? How do you know? Because you are not analyzing pancreas, right? The same way. So, I just don't know, but it's just hypothetical ideas that you can actually judge. No, no volunteer will agree. Yeah.
And one more thing, another you told inhibitors. Have you tried the different structural analogs of inhibitors and the
Yeah, we did.
potency of those?
Yeah, we will talk in third day, I think fourth day. Yeah, because I have to come to the drug screening studies. Yeah, we'll talk about during the drug screening. Yeah.
One more thing is different cancer types. So they will metastasize in different directions. So some will go to metastasize to lungs, and some will go to heart.
Correct. Correct.
So what would be the driving force for them?
It's not a driving force, it's about the blood vessels, how it is connected, and that's all. So it's all how the whole system is connected. Blood flow and for example, you take a spleen, okay? I inject the cancer cells to spleen, it will go to one of the organs so directly. No, not other organs. It's like that. How the blood flow is, in particular organ. Right? It's all about that. Always. So that's why I was telling you about not only metastasis, even any tumor microenvironment, right? That's why I was telling you how they interact. For example, LIF went from tumor intrinsics to macrophage and it bound there and activated STAT3, right? So it is true, it is activated STAT3 there, right there. All people published on actually LIF activated in the tumor cells STAT3, but what we saw on the macrophages, so that is something unique. Yeah. So like that, it probably people don't think, you know what I'm saying? Probably they are doing it. Probably we did it, things like that. But you should not hesitate to conduct any type of experiment you want to do if you can do. But you never know what you end up with, right? Remember, there were days that we used to talk about tumor cell signaling. There's a signal on the tumor cells, and you all studied in MSc and markers, and you all studied in MSc how the tumor cell receptors, T cells, B cells, and all. Today, you have to think the same way on any other cell type that you take. Okay, the same biology. Things are changing, so you have to think like that. You broaden your way of thinking. Yeah.
Nowadays, this personalized medicine based on the genomics map of person. It's coming like that. Personalized medicine for each individual, like that. With this crash as well as TP53, can you suggest some person who can take alcohol or cannot take alcohol so that you have a greater chance of having a pancreatic?
Do you think that people believe you? If you suggest to me, do you think that I will be all right? I will not be all right, right? So I will say, are you mad? I'm all right, right? So it's about the. Can you suggest? Can you suggest? No. Can you suggest? I don't think so. People won't take it easily, right? Oh, you are taking this. I think you are getting. What if he don't get it, and they're gonna blame you, right? But see, anything that you suggest, right? Either you have to be a doctor or a researcher. If you're a researcher, you suggest to whom? To do the research. You cannot suggest a patient. But as a doctor, suggesting a patient means that he has to have the authority to suggest, right? If anything happens to the patient, so you have to have the consent.
No, what I am telling is that as you know, the addiction is increasing. Number of person addicted or consuming alcohol is increasing. No? By telling this, we can, I think, reduce or stop the individuals.
I am not doing that, but my role is to conduct research and establish the role and study the target and get into the clinical trial. Based on the biology we study and drug we study and give it to the oncologist, not oncologist, medical oncologist, and they will conduct the trial and I just watch. Definitely, our study shows. But remember, see, again, you're actually talking about public policy. I am not a doctor. I'm not a clinician. I'm not seeing the patient. I'm a researcher. I only give you the data and suggest you this is how it's going to be. But what are you going to do? And medical oncologists will say, okay, let me think about it. So who's selling the drug? They say, okay, this company. Do we have authority to use the drug? And their willingness. And if they are ready, they do it. And when it comes to patient, and we have to tell ahead to the patient that what we are going to do on you. And they have to accept it. Then only you can conduct. Right? So, we are not a policy maker, right?
What I am thinking is that if you do this, then there may be increased cases of pancreatic carcinoma. If the persons, they are aware that
that's what we are.
Greater chance of getting a pancreatic carcinoma if I consume alcohol, then he might avoid taking alcohol and there may be lesser chance of pancreatic cancer.
Definitely. That's why we are studying, to make sure that it actually goes to people, they understand it. But someone has to do the P53 mutation studies, right? Yeah.
And they have to aware the person.
Yeah. It's coming up. Remember, after the human genome, there are a lot of things are changing. So, yeah. Anybody else?
How vital these genes when you knock out?
Vital means?
For survival of the organism, for animal.
It depends on the gene. For example, remember, we are knocking out specifically in the pancreas, not the whole body. This is the Cree. So we already know the gene is, we can activate it, either delete it based on suppressor or the activator, specifically in the one organ, right? So if I delete or activate one mutation or gene, we delete the CREB. I cannot delete the CREB, which actually CREB has a normal function role, right? It can affect the pancreas. So that's also important to understand what is CREB role in pancreas normally with the disease. That's why those studies are. In a normal, what happens to the CREB? There was no CREB. You saw that? There was no CREB in the normal pancreas. Only when you have alcoholic chronic pancreatitis, only we saw it. Only when you have a KRAS mutation, only we saw it. Otherwise, there was no CREB. Yeah.
Is that CREB is expressing in other type of cancers also? Have you studied lung cancer?
Which one? Alcohol?
No, CREB, expression of CREB.
Yeah, I showed you a couple of my studies. I showed you gastric cancer, esophageal cancer, cholangiocarcinoma, so kind of like that.
At that time, when you use even pre-log system, will it not affect the other organs?
No, because we are specifically doing it in the pancreas. That's the Cree for the pancreas only. Yeah. Oh. No, we make the knockout, whole body knockout first, and then we specifically cross with the specific Cree knockout mice. Yeah. Good. So I think you guys have a tea break, right? Yeah. Is tea ready? Oh. How is it coming? 5 minutes, okay. You can take a break and have a tea and then come back.
Sir, all these markers what you have shown is confocal microscopy. All they are not expensive.
Which one, confocal?
Green for amylase.
Yeah, they're all, a little bit, sometimes what happens, some markers might work, some markers may not work. So then you have to go to another company and buy it, right? So accordingly, how much you want it, for how much cheaper, according to you, you have to compare, right? Yeah. For me, $100 is not cheaper, right? So I'm just asking you. So for me, $250 is also not cheaper. Okay, that's okay. So when you say cheaper, means $1,000. I mean that is expensive. I like that. Huh? Correct. Also, sometimes what happens, it depends on the company. Yeah, some companies, cell signaling is expensive compared to some companies. So you're saying cancerous patients have a pain? It depends on the cancer. Some cancer you can know early on. Okay, some cancer like pancreas, you'll know late stage. Okay? Some cancer you will know early on, right? Yeah. No. The cancer patient, not all the cancer patient will have pain. Because it also depends on the organ, right? In some cancer organs, in some organs, the cancer is just nothing. They don't give you any pain unless until that is really. For example, in pancreas, right? If it occupies most of the pancreas, the cancer cells, remember how anything can digest, right? You get other problems in other organs because it's not digesting the food. There's an issue with the other, there's a diabetes also can come. There's a lot of things, other things. So it all depends on the pain because of cancer or something else, right? So you're saying that why brain is not sensing the pain? It depends on what type of cancer you will have to get the pain, right? Usually, it depends on what organ you are affected with. So whether cytokine give you pain? Inflammation. Yeah, of course, it's inflammation. End of the day, it's all cytokine, chemokines. Uh, you know, uh, Whether they are giving the pain, I just don't know. But inflammation definitely increases the pain, right?
Is there any circulating biomarkers for the diagnosis of pancreatic cancer other than histopathology?
Yeah, there are. There are. There are circulating for the human. Yeah. Yeah. See, whenever you have the blood sample, doesn't matter when. Yeah. But that marker has to be there, right? That marker, what if that marker is only on when you have a tumor? What stage of tumor you will have, that marker has to be activated, right? That is it. That's also. The marker that what they have is after surgery, something. Yeah, it's a K, yeah, CA111, I think, something. Yeah, there is a study, big study from Vinod in MSK. You can Google it. It's a big vaccine study is going on right now in the human. Um, so yeah, there are. Huh? No, there are a lot of trials. Yeah, there are a lot of trials. You can go to clinical trial. You see the type it vaccination for pancreatic cancer. There are a lot of trials running. Okay. First thing, you can ask questions, anything that you have a tutorial material, the tutorial 1 material that I added there, some of the general questions, like for example, what is cancer? Like, it's actually baby steps, okay? You don't have to worry about, what cancers and all. Why I added this? Because I think you have to start thinking. It's important to think. Okay, like many times what we think is that we always think that we know this, right? Even though it is a simple question, right? I think important to think, according to you, what do you think is of cancer? And also, we want to know where you stand, so that next time when I'm doing the technology and things like that, I can concentrate on, making sure that I'll tell you or teach you something that very basics that you will also learn, right? So it's hard to know unless you tell me something that what you understood about cancer, why you are in the program, and to learn. Okay, it's fine. So you're in the program to really do something cancer research, great. If you are in the program to understand what is cancer biology, that's not enough. Okay, this program is a little bit hardcore, so you have to go beyond. Okay, if you are coming from different field to this field, to cancer biology, understanding the technology, it's fine. So you'll get something, right? If you're already a researcher, if you want to know how to do advanced research, also you will be fine, you can understand. But probably you might need more interaction with me. Okay, this is communicate with me, also fine. But probably you may not get much from me. But you're starting. You're thinking to do it, right? Probably that initiative research, okay, maybe it's difficult, but unless you have some experience of research, right? Like that. So when we say cancer, right, we're going to tell you what's cancer, maybe in the next talk, tomorrow maybe, if not today. But I just wanted to know, anybody thinking anything that, other than that, generally what everybody is thinking, right? If anybody has anything, you can tell me, so we can discuss, okay? If you don't have, we'll move on to, why does cancer occur? What are the primary causes of behind the cancer development? You know what I'm saying? You may also, you can stop me anytime and ask me question, it's fine. So you all may be thinking, right? And also, a lot of people, generally outside, also people think, why are we getting the cancer? And what is actually, many people ask me, why do we get cancer, first of all? And I'm eating this, do we get cancer? Right? This question always in our mind, nobody knows exactly what it is, right? It's hard to know, because nobody knows, right? It's very difficult to know. Only we can model and we can study, I can show you smoking model also, we can show you alcohol, I can show you a lot of other risk factor, diabetes related, high fat related. So we have done all those kind of studies. But important is that, so we also don't know.